Hello everybody to session B now of our today's performance based on track measurements or performance based on measurements. What is the topic now in this session B? My name is Stefan Freudenstein. Everybody who couldn't see the introduction in room A now. We will start now with the block before noon regarding all topics of measurements. Measurements are important to understand the behavior of the track, and there are two options of measurements. The one option is to measure the behavior in track, and the other option is to measure from the vehicle, from the driving a car. And we will need both options to see and to understand what happens to our track and what is important to understand the situation of the track. So therefore we will have now 4 presentations before noon. We will start the first presentation with Ferdinand Pospischil from the Technical University of Graz with the topic of track measurement in operation. The second presentation will be given by Florian Auer from Plasser and Theurer about turnout maintenance and the next generation. The third presentation will be given by Andreas Oberhauser from Wiener Linien and Alfred Pölinger from voestalpine railway systems, monitor turnouts and take control. And the fourth and the last session before noon is Manfred Arndt from voestalpine digital pacemakers in the European railway industry, insights from a rolling stock monitoring perspective. So I think this is a quite interesting program here in the session B. But we'll start directly now with the first presentation. And I'm quite happy to introduce Ferdinand Pospischil. Ferdinand, nice to see you here in St. Pölten at voestalpine at Weichenberg work. You are now since a couple of months, a couple of weeks in TU Graz, and you're working there. Do you enjoy your work at TU Graz?
Yes, thank you very much, Stefan. I'm in TU Graz now since January, and I really appreciate it. And having the chance to speak to you guys in all over the world already now is a great pleasure for me. And I hope you will enjoy it as much as I will.
Ferdinand Pospischil did his master degree at the Technical University of Munich, so we know us quite well. And later on, he was a couple of years in the industry, in the railway industry. So also Ferdinand knows both situations from the research situation actually, but also the situation before in the industry. And therefore, I think we will get a very nice presentation now. Ferdinand, the floor is yours.
Thank you very much. And welcome everybody in all over the world from my side as well to the area B. And I would like to start with you to have an overview to track measurements in operation. What will we be talking about in the next 25 minutes? First of all, I would like to lose a few words about the age of simulations. Then talk about measuring versus collecting. Then the topic might be data, where should they get them from, how to gain track information. And after that, we will have a look at what kind of measurement possibilities are out there. Stefan already told you guys a few of them, but it's a whole bundle of measurement possibilities. And then I would like to tell you something about measurement concepts and how a measurement could be in theory. Then some basics, and in the end, I would sum it up with one, I think, future-based measurement system, the fiber optic sensing, and a whole system approach in the end. So let's start with the age of simulations. I think today simulations did become more and more important, and we want to simulate everything. Why do we do that? Because, first of all, they are very quick and they are cheap. Especially in the last few decades, our computers gain much more power, and we can do 30 years of degradation in track in 30 minutes or 3 minutes on the computer. So there is a great advantage that we have in this area today, but still they are simplifications of the real system and components. So we cannot put the whole real-life system within our simulation. So what we need to simplify that. We need to put it back to some models, and this runs then in the computer. What we need, or why do we do that? It's also because we get information of layers where we cannot have a view without destroying our component. For example, we can see stress levels within the rail where we cannot have a look inside without any simulation. But as I said, simulations are mostly, we need rough assessments from the outside or surrounding parameters, for example, the subgrade or the ballast. You know, we are now here in Wörth, and you are all over the world. So if I talk about ballast and the technical stats of this ballast which we have outside here, then it's a complete different ballast to the ballast you are living in, where you are and what you are used to. So there you can see it changes from area to area, so we need to have a closer look, not only from simulations, but also we need to see what is out there. Simulations, what do you need? You need of course, you need a goal. We always need a goal, and we need input parameters, and we need a calibration and a validation. Sometimes it is quite easy to calibrate a simulation with another simulation. And this simulation might have been calibrated with another simulation, and that one was also calibrated by a simulation. So in the end, in every simulation, we have a little change from reality, because it's only a rough assessment. And then we have some information which has it's not a proper view of the real life track, but we don't recognize that anymore because we don't look on the track. So this is very important, or for this reason it's very important sometimes to step back from the simulation and go into track to see how do they really perform. So when we are outside and we do measurements, you know, we can not really everything, but we have the possibility to measure quite a lot. But if we measure quite a lot, we do have data which will be overwhelming. With all that data, we need to work, and we need to get the information out again. And this is why we should think first, what is the information we want to take out of our measurement? What is the need to know basis? And then, of course, beforehand of every measurement, we need to have a look, how do we want to perform our measurement? Do we want to make a sample? So just go there, do one measurement for a couple of train sets, and then go back? Or do we want to put our measurement into track, wait for, let's say, 5 years, 10 years, and see some degradation rate? Of course, if we go out there, if we do a one spot measurement on, for example, 1 day, we thought we should think first of what kind of train set are we awaiting? What do we expect? How many trains should we measure? Because only if we have quite a number of influences and trains, then we can actually work with our measurement. So this is the sample rate. We should think of how long should we be out there, and how many trains we should measure. What kind of measurements are there? Stefan Freudenstein said it already. We can start with a manual inspection. We can go out there and do a measurement by hand. So we can go out and have a look, for example, how did the rail profile change over the day, or over the years. We have the onboard measurements. So we have trains and which are equipped with a lot of, for example, acceleration sensors, and they give us data as well. Then we have the track recording cars. in some companies and infrastructure companies, they're more into the normal set, like in the ÖBB, and in other countries, I think it's not that common, but it's basically one of the big measurements. Then we, of course, we have the in-track measurements, and then we have smart assets, which will gain importance in the future. And of course, we have others, like fiber optic sensing, which I will be talking in the end. And then in the future as well, data from drones. And then, of course, also we shouldn't forget about that, the laboratory. To have a quick sum up why or what are the benefits of going into laboratory in track or onboard and track measurement cars. If we are in the laboratory, we have the great advantage of one single component. We can have a close look upon one single component. We can put all the other influences aside, and we only have one component, and it's repeatable. Most of the tests are standardized. So if I do the test here in Graz, for example, Stefan Freudenstein does the same test in Munich, and you might do the same test in Buenos Aires or Sydney, there should be the same result. This is laboratory. It should be the same result if we use the same norm and the same testing method. It's a great benefit, and of course, this is why it's used for approval tests. If we go into track, it's a bit different. In the track, we have the benefit of one exact location. We go there and we can choose an exact location. We can say, yes, we want to have a look at this frog in a turnout, for example. We can see multiple train sets. We can see loads. We can see speeds. We have the load path. And this is something which is very unique for the in-track measurements. We can see how the load and the pressure and the acceleration, for example, is going from the wheel-rail contact down into the subgrade. We have a high resolution, and of course, as I said before, we can do single event measurements or long-term measurements. Also in track, we can have a very component sharp evaluation. So if we want to, for example, see the influence of a different rail type, we can swap the rail and see how does the whole complete track perform with another rail. How does, for example, a hardened head perform? And then, at last, we have the onboard and track recording car. The benefit of that system is we have a network-wide information. So it's not only on one spot, but we have the whole network. So the backside of that is we only have the same load in every measurement because it's this track measurement car. It has one axle load, it has mostly one speed, and there's no, for example, high-speed train and then a local train or a cargo train running through. So it's always the same load, but the benefit of that, again, we can compare it. We have no extra track occupation time. Track occupation time in future will be one of the big things to talk with the infrastructure managers because they don't want us to go into track to perform measurements. Of course, we are expecting more traffic within the railway system. We want to shift people to use the railway, but then, of course, the maintenance times are shrinking down, so we cannot perform our measurements and say we want to have, for example, 2 weeks of playing time within the tracks. Algorithms are unified. So if I have a track recording car and go all over our network, it's the same algorithm and the information will be the same out of the whole system. So this is very nice to have a unique point of view and, of course, a network-wide history. So we can look back if the recording car goes in our network, for example, 3 times a year, we can have a look back 10 years, how was it the same spot 10 years ago. So let's have a look, what can we actually measure regarding in-track and onboard and track recording car. For example, speed. Speed, of course, is on both sides possible. longitudinal rail stress. In track, it's relatively possible to measure that. On boarding car, on a track recording car, I don't think it's possible at the moment. The rail foot stress, the same thing. Vibration and noise, of course, you need to step outside the track to get this information. RCF, okay, as soon as you know the problem of the rail contact fatigue, you know what you have to look at, but you can only get this information if people are actually out there walking, doing a track walk and see, hey, there's a new problem. What kind of data do we get, and how could we analyze it and see in our track measurement car, for example, where else do we have this situation in our car, on our track. Yeah, we have rail profile, subgrade stiffness, ballast condition. We can do all this. Deflections, of course, in the track recording car, the whole superstructure. In track measurements, we can evaluate component sharp. So we can see how, for example, this is the deflection in the rail pad, which kind of deflection is coming from our undersleeper pad or subballast mat or from wherever. So as you can see, we have both systems are very, very important, and I think together we get a complete view of our track, and we should use both of them to get out to know our system better. If we want to have a measurement, if we go out and say we want an in-track measurement, what should an in-track measurement perfectly look like? First of all, we did choose a measurement section. We say, okay, this is our measurement section, so this is our track without our measurements. We do a zero measurement and see how does it perform at the moment. I'm sorry. After that, we do a track renewal. For example, put in a new component. And then, of course, we have a lot of time passing by and trains passing by our track. And then we do an effect measurement. So now we have the degradation from our track without measure to our track with measure. This is the one part. And it could be a single event now, or it could be that there is no influence at all and it's a normal degradation. So what should we do? As soon as we do our zero measurement prior to assembly, we should go next to our measurement section and set up a reference section and do a measurement there. So we have a check measurement. We can see, for example, is the subgrade nearly the same? So is our data comparable? And of course, after the same time, we do a check measurement again. So we have an effect measurement, and now we get the complete picture of how did our measure that we took in our track perform. But now we need to choose the right spot. What kind of tumblestones could be on our way? First of all, we need to have a look at the radius, gradient, and landscape. The bottom two pictures, for example, are on the same spot. One is in the summer and one is in winter. So as you can see, there is a shadow. There's mountains there. So in the summer, it all looks quite well. The track comes out of a gorge and then goes onto a dam. And this will show in the winter the different phase. The complete superstructure is frozen. So depending on what kind of measurement you take there, if you, for example, do a year measurement which will last for 2 or 3 years, you do have to take this into account that one part of your measurement section might be frozen. Top right corner, same thing. You have this the track with a lot of points where it's holden, and for example, sorry, the movement of the track is not very stabilized. Next thing, you need to know which kind of superstructure you have. Are you in the ballast? Are you in the slab track? The next spot is what kind of, how much time did pass by since our last maintenance? Is it only a few days or has it been years? And then, of course, the plant maintenance. And this is very important to see and to talk to the people on the track, whether they do have anything planned. For example, down on the right-hand side, this was one of our long-term test sites, and just the day before we got there, they had some ballast leftovers, so they just dropped it there, and they didn't know that we have this this measurement there. So you need to be in constant contact with the people on the track. And of course, accessibility. You can see in the top picture, it's perfect to get there by car, but there's no energy. So once again, you need to get your own energy. And as I said before, the weather. Weather is quite important, and yeah, depending on what you want, what kind of measurement you want to perform. And in respect of choosing the right equipment, you need to once again have the goal. You need to have a look at track availability. Can I actually go into the track, put up my measurement, or do I have to be quick and do it from outside? What kind of speeds and acceleration do I expect? How much pressure, how much deflection? What kind of sensors do I need? What kind of superstructure do I have? And then, if you have all this, I would like to lose a few words about the fiber optic sensing and the distributed acoustic sensing. This is something Mr. Ivan Vidovic took a closer look in his PhD thesis, and it relies on the effect of Rayleigh scattering. You can think of it, it's a fiber optic line cable, and there's every few, like 50 meters, there's a hub, and there's a light beam sent through. And as soon as there's a little deflection or a vibration touching the cable, there's a backlight scattering. So you can measure how much light is coming back and at what time is it coming back. So you know where it has been and how much was the how much force has been there. So for example, you get one of those pictures. What can we see here? We can see a lot of trains passing by, but then we have these three areas, and we have three tamping sections, for example. You can see the section length, you can see where it started, where it ended, you can see the working speed, and of course additional information as well, like tamping frequency, ballast penetration, and much more. So this is a future technology which I think will gain way more importance. So in the end, let me sum it up like this. Everybody is taking data and information at the moment. It doesn't matter who it is. If it's the railway infrastructure companies, the train operating companies, the industry, the maintenance companies, research and universities, we also do a lot of measurements, and the suppliers, all of us, we get data of the superstructure and all of the whole system. But who owns the right of the data to keep it? Should we not share it? Because only if we all work together, I think we can put this whole system to the next level. Only if we work together, if we share our information, if we, for example, like the trains, like Siemens, they do a lot of measurements in the track. If we do on-track measurements and we have their information, first of all, if we work together, then we have the whole side of the complete system. So please, let's work together for a better performance on track. And that will be all from my side. And thank you very much for listening and watching. I hope you did enjoy it.
Ferdinand, thank you very much for this kind presentation. quite interesting to see all the topics what you have developed here and what you showed us, especially for the types of measurements what we can see. What do you think is the most important thing for the exchange of the data further on in future?
I think first of all we need to know who is gaining data, and then we need to be free about the sharing. So I think we need one perfect, like an institution who is able to collect data and have a look at it as well. But because if we only collect data and put it down into the cellar, there's no benefit in it. So we need people who come from the track, who know what they do with the data, and then have a close look on it. Yeah.
Okay, thank you. So if there are further questions, please show me your questions. Up to now, I can't see anything. Maybe a second question from my side. What do you think will the measurement change? How will it change in the future years? You showed us some topics like fiber optic measurements. You know, also in Munich we do two-dimensional optic measurings or maybe three-dimensional optic measurements. What do you think will be the future? I think this will be the future because, as I said, track occupation time is gaining importance. So when we can do measurements and get data out of the track without going in the track, without, for example, in a tunnel, nobody wants us to go into a tunnel and perform measurements where we need, for example, to remove the plates to go down to the substructure. So if we can do all this without touching the track, I think this will be the future where we have to have a close look upon. Yeah, I totally agree. It's the same what I think. It's very hard to get access to the track.
Yes.
And if we do the measurement on a single location in track, we always have to entrance the track. We have to reduce the availability of the track. And so this must be our aim for the future, that we find solutions how to do the measurements from outside of the track and how to gain this.
We want, with the measurements, we want to get a better performance and not delays because of we're performing measurements. So this has to be, working hand in hand.
Okay, I don't see any further questions in the chat room. So if there are no further questions, Ferdinand, first of all, thanks a lot for your kind presentation. Thanks a lot for that, what we have seen. And later on, maybe we will have a short discussion, and then good luck for the future with your new type of measurements.
Thank you very much.
Thanks, Ferdinand.
See you later. Thank you.
So we will come to our second presentation in the session before noon now. The second presentation will be given by Florian Auer. Florian Auer is the Director of Technology and Innovation at Plasser and Theurer, well known in the railway business since many, many years. If I remember correct, since 2002, so nearly 20 years, he's now involved in the railway business. Previously, he was at ÖBB, and he was the head of lifecycle management in ÖBB. And therefore, Florian, we know you quite well from different kind of jobs what you have done and different patients what you have done, and especially I think this is the right word for you. It is a patient that you are working on the railway system. So Florian, please come to the floor. Your presentation is about turnout maintenance and the next generation. Do you think you, as Plasser and Theurer, you are on the right way for the turnout measurements and the next generation?
Of course, that's why I'm standing here. I think we've learned from the past. We have learned that a machine producer for so-called yellow machines has to grow when it comes to the new world. to the future. And I think since 2016, we've done a couple of steps to come forward. Of course, we are not at the end, not at all, but I think we have done the right strategic decisions in growing our company, I'm sure.
So you gave us now an appetizer. I'm quite happy to have you here. And please, I'm very interested in your speech.
Thank you, Stefan. Let's work together. I think that's the best message that I could get up from Ferdinand before. My speech is about the track maintenance machines and the next generation on it. First of all, I could just do it again. Let's work together. It's a message that also comes from our company as a Plasser and Theurer group, and therefore I really say thank you. Thanks for the host. Thanks to voestalpine to having the chance to do a speech here. I'm now, on the one hand, Director of Technology and Innovation at Plasser and Theurer. On the other hand, I'm also doing the strategic decisions in digitalization. So what I want to do is now to combine the old traditional Plasser and Theurer with the new one. And our owner, Mr. Max Theurer, is pushing us forward to really grow into this new future. And we want to be an active part when it comes to track maintenance in the future. Definitely, yes. But let's keep it simple, one step back. First of all, why do we have that passion in railways? It's about the success of it. It's, first of all, a long history, more than 175 years, and the system itself is more than simple when it comes to the plane track. It's rail, sleeper, ballast, subsoil, of course. It comes more complex when it comes to switches and crossings, of course, yes. But also, when it comes to the switches and crossings, one message is clear. The more simple the construction, the more modular it is, the longer the maintenance intervals. And therefore, I'm really proud to have a lot of discussions and partnerships and projects together with voestalpine, because, of course, we both could and can help each other in the design of the switches and crossings, as well as on the design of the yellow machines, on the on-track machines, because there's, of course, a clear interaction to it. And it's really good to be in line with each other globally. So, first message, the more simple the design, the better it is for all of us. And the longer the inspection intervals, the maintenance intervals, and the lifespan of the track. When it comes to the track work itself, the infrastructure manager's duty is to plan the right measures at the right time, while the second track is still in operation. And what we see now as Plasser and Theurer, that the yellow machines have to fulfill more requirements than in the past. In the past, it was only driven by performance. Single sleeper, two sleeper, three sleeper, four sleepers, and one time 2,000 meters of track tamping per hour. But the infrastructure managers are still demanding for more, and that's what I want to highlight now. So it's a yellow machine. It looks pretty. We have the passion for it, but inside the machine, there are now more functionalities than beforehand. And that's quite important for all of us, because it gives an added value to the infrastructure manager, to the producer itself, to the machine operator, but also to the supplier of the solutions. We, as a Plasser and Theurer group, we stand for end-to-end solutions for the track maintenance. To bring it more precise to the point, we stand for end-to-end solutions for the installation, the monitoring, and the restoration of a precise and durable track geometry. That's what we stand for, and all the effort comes into this message. So what you see here on the slide is a new version of a yellow machine, and the message here is clear. We believe in process safety. So everything, we do not only look to the machine when it comes to the to the new features on the machine, we also have a look from outside. So what we want to do is that the infrastructure managers, as well as the machine operators, have the chance to use it in the best way. And that means that the machine itself is not designed perfectly for the work itself, for the core work. And the core work is, as I said, the installation and the restoration of a perfect, precise, and durable track geometry. But now what we see is that due to the pressure on us to do more in the small slots in between the train traffic, we have to put in more functionalities, such as the pre-surveying of the track. We're doing an operator assistance with an real-time artificial intelligence solution. A very new feature is the condition monitoring of the work units, but as well as the condition monitoring of the ballast bed, very important information for the asset managers. And at the end of the day, we also help and support to do a more simpler handover procedure when it comes to put the track back into operation. Let's start with the first one, with the pre-surveying. Due to the fact that we do not only deliver inspection vehicles, tamping machines, but also inspection vehicles, we were driven to work on new modular systems. And that's first of all the ground penetration radar that comes originally from the inspection vehicles. And the second one is the stereo camera system to detect and measure the absolute track geometry of a track. So the precise 3D trajectory of a track, the precise absolute track geometry. And we took these two functionalities from the inspection vehicles and installed in the tamping machines, such as the new tamping machines also have the ability to measure the absolute track geometry when they do when they run from one side to the other, or during a night shift and during the day they work. And the other thing is we do a complete screening of the ballast bed, such as that we measure the moisture, the subsoil condition, and irregularities inside the ballast bed. It's a very new R&D project, maybe you heard about it, is that we also want to find automatically the bombs from the Second World War, because it's still, until today, a big problem when it comes to do a ballast cleaning work. And therefore, it's an additional feature originally coming from the inspection vehicles, but now also to be installed in a tamping machine. When it comes to the design of the work unit, of course, that's the traditional core know-how of Plasser and Theurer. What I want to say here today for this part of the tamping machines is that it's now the time to not only look from a design engineer on the work units, we can do it in a more holistic way, such as we have an own simulation team with a discrete element method simulation. We can do a precise simulation of the whole track work, that is the restoration of a precise and durable track geometry. So every single detail here is well simulated. Then we go to Stefan's laboratory with our new working units. We test it in the laboratory and we bring it together with the field tests, because we also have the chance to do tests with the first maintenance and prototypes of maintenance machines together with the Austrian Federal Railways. And so now we have really the chance to quicker design more working units that are also clever in the sense that the machines now get sensors ahead of the machine. And this is one of the latest machines, also running here at Austrian Federal Railways. But the system itself is also delivered to some of the first customers. What you see here is the so-called assistant system. The machine itself detects and measures a precise 3D copy of the track. Some could call it a digital twin of the track. And in real time, with only 2 meters of difference, but in any case it's enough to steer the machine. The real-time artificial intelligence computer software detects all the obstacles and the objects of the track and makes proposals for the operator. So historically, the operator had a lot of joysticks and pedals when it comes to tamping, and even more when it comes to the tamping of a switch and crossing. Switch and crossing tamping is, I would say, the Formula One for the operators. It's not that easy, and with the new system, we can really support it. This here is one of the first tests we did in Austria, in a test track in Linz. And what you see is here that every single detail of the position manipulation of the tamping machine here in the turnout is done by the system itself. So all the proposals come from the internal real-time artificial intelligence computer. And the operator is still in charge of safety, and he presses the pedal, and then he starts to do the correction of the track geometry. That's it. So what you see is here really a real-time application on tamping machines. The machines become more smart due to the fact that it's not that easy to do the track geometry restoration in switches and crossings. And what you see here also is the screen of the assistant system, and you see a lot of additional information on the screens, and that's what I want to highlight now. The latest machine from Plasser and Theurer are having a condition monitoring detection tool for the ballast, as well as the condition monitoring for the working unit, because the sensor is designed in a manner that he sits directly, let's call it, at the heart of a tamping machine. And the sensor itself can calculate and detect signals from the track bed as well as from the machine itself. And we have really the chance now and to do R&D projects together with infrastructure managers such as ÖBB, SBB, etc. in the framework of the Shift to Rail EU founded. And it's really good to have now the possibility to detect the ballast condition with the tamping machine itself, because due to the fact that the machine itself holds the track panel mechanically and the tamping tines are in direct physical contact with the ballast bed, we can really 35 times a second detect the stiffness of the ballast bed, and via a clever and smart algorithm we can highlight and calculate the ballast condition out of the sensor sitting on the heart of the working unit of a tamping machine. And this here is a so-called new tamping protocol. It's another smart feature, because at the end of a tamping work, every single quality-related parameter is now handed over in a very transparent way. So there is no doubt anymore, at the end of a tamping machine, the track geometry quality is perfect, precise, and durable. If it is not, to the one fact or to the other, to the one reason or to the other, maybe due to the fact that the ballast bed itself is completely worn and has insufficient bearing capacity, it is transparent. It is handed over in a super transparent way. And that's what we stand now for. We want to put in additional features into a tamping machine, so at the end of the day, the track work is done perfectly and precise. But there are still things to do in the future. I'm more than aware and sure that it makes sense that all of the sector, that the infrastructure managers, the machine operators, the suppliers of yellow machines, as well as of the superstructure and turnouts, that if we start to collaborate in a data exchange way, that there is an added value for all of us. Because so far, to put it frank, the values here, what you see here on the screen, is a perfect, precise 3D copy of every single component of track and the turnout. But for us as a machine producer, it's trash. So we just do not even store it. I think there's a lot of things to do together with the partners, and I think within it should be our core work for the next 5 to 10 years to also cooperate in this data and information exchange policy. While we ourselves, I think we have really done a good job in bringing in added value to those who are using the machines for the machine work itself, so for the restoration, the monitoring, and the installation, monitoring, and restoration of a precise and durable track geometry. We have integrated surveying into the tamping machines. No track workers doing manual surveying anymore. The assistance system increases the quality, especially in switches and crossings. It decreases the faults that could be done during a night shift, of course. And the acceptance of the work is done in a complete new and different way, in a holistic one, where every single quality-related detail is handed over to the infrastructure manager at the end of the day to help him to more easy put the track into traffic again. But as I said also, I think we are not at the end of the day. There are still open points, and there are things. There is information inside the tamping machine that could be also even more used to for the infrastructure managers as well as other suppliers, such as voestalpine. So I would say, Stefan, if you ask me, are you on the right way? I'm sure, of course, that's my job to say, yes, we are on the right way. But I think the next job is not to connect the machine, the one machine with the other machine, the one yellow machine with the other one. I think it's now about to connect the whole sector, such as the institutes, the infrastructure managers, the machine operators, the suppliers of the track and all the superstructure, switches and crossings, as well as the producer of a yellow machine, a traditional one. So I think we are quite on a good way. Now we can say smart solutions help and support the track and the machine health. And I really look forward now for the future, for your questions. Hopefully I could present it in a way so that you could get our message. Plasser and Theurer stands for more than just yellow machines. There are a lot of smart features on the machines, but there's also a clear message here that I think there is the chance for all of us, for the whole sector, to even more use the information from one hand to the other and back. That's it.
Florian, thank you very much for this perfect presentations, as always when you give us a speech. Well known in all over the world in different speeches. Thanks a lot. I think it was quite interesting that you're showing us that you're not only selling a machine, that you also are providing technology, and that you will help us to understand more the track. And so maybe one question from my side. We have the possibility to do the track monitoring on track, what we have seen especially from Ferdinand Pospischil before, or we can do the monitoring from the machines, from the rolling stock on the track. So where is the big difference, and what do you see are there any benefits, and can they cooperate each other?
I'm sure they will cooperate each other. A starting point, of course, we first of all, we have the perspective of the machines and the tamping times. If we are in mechanical contact, physical contact with the ballast bed, we can detect everything around the track panel itself. When it comes to the maintenance work, we can do a physical test of the track, such as the rail fastenings. You are more than aware of it, but also on the ballast bed condition. But of course, you need a slot. You have a time slot for the maintenance, and you're using it in a perfect way. So the machine becomes also an inspector of the track, and not only the machine that is doing the work itself. But everything around it has to be done outside of the slots. And I'm sure that with a forecast, I would say, for 5 to 10 years, we see the first presentations showing drones measuring and detecting conditions of the track outside the track without the need of a certain slot. We will see a high and increasing number of autonomous measurement systems installed on locos, as well as the traditional data coming in a very holistic way from the track inspection vehicles. So I think the idea, the core idea for the next years must be to merge the different data sources together. That's it. Starting from very traditional physical view of Plasser and Theurer, using sensors from voestalpine, but maybe also with a perspective of drones. I think that the idea of the holistic concept of the future will be to have first unloaded measurements from outside the track without using any slot, and in addition to it, you have the loaded measurements. And I think the combination of the smart combination of the loaded and the unloaded measurements, that will be the future from my perspective.
I totally agree, and I also, from my point of view, it's very important that we calibrate and validate the systems from both sides, what means also from the track measurement and also from the measurement from the machinery. So this can be the benefit of a cooperation of both systems, and I think you showed this quite well. So I heard there is one question, but I can't see it up to now, the question in my tablet. Is there a question from the audience, or please send us the questions if you have any further questions. Can you help me maybe for an additional question if there is one? I don't see, no, there is no additional question. Maybe one question from my side also. You know special geometries in the turnout area, for example, like FACOP, what is well known here. Can you also tempt this special geometry, and how can you detect it in a certain line?
Thank you for the question, because I have it on my desk several times a year. Of course, the machine itself can work with it, but the operator, they have to be learned how to do it. So, of course, yes, the machine can do it, but when the operator, out in the night, in the shift, he selects the wrong rail, that is the reference rail for him, he could come into trouble during the night. So the machine itself can do the job. If normally there is no problem, but when it comes to non-experienced operators, in during some shifts there are problems. But as I said before, the idea of exchanging data could, at the end of the day, help and support all of us. Because if we find a way that the machine itself knows beforehand that there is the kinematic gauge optimization FACOP in the turnout, he automatically would select it. So I would say here we are now in between from an old traditional way in saying the operator is in charge of everything. Sometimes there are some problems during the night, and what we also want to do now for the future is that the machine itself automatically also detects the FACOP, and in this case we are completely process safe.
Perfectly,
and the trains are running perfectly and smooth.
Very fine, as we know it from Plasser and Theurer. So I will not ask you now whether you are on the right track now and you're on the position that the future will come, especially for Plasser and Theurer, with new technologies. But later on, maybe we have a short discussion before we end this session in the morning. So, Florian, thank you very much for your kind presentation.
Stefan, thank you for your words.
See you later on. Okay.
Always good to cooperate with your institute as well.
I know it. I know it. Also from my side. Thanks, Florian. Okay. So we will come to our third presentation. The third presentation will be given by two presenters. First, Alfred Pölinger. Alfred Pölinger is Senior Vice President, Customer Management and Marketing for Diagnostic and Monitoring Technologies for Infra at voestalpine Signaling. And the second one is Andreas Oberhauser, Head of Permanent Way at Wiener Linien. He's now since 13 years at the Wiener Linien, and previously he was at the university in Vienna. So also a guy which is well known to the research at the universities and now to the reality in track and the problems what you have to solve all the day and all the nights, especially I can imagine at Wiener Linien. So your presentation is, the topic of your presentation is monitor turnouts and take control. I'm not sure who will start with the presentation. Okay, Andreas, please come to the desk. So good luck for your presentation. Enjoy it.
Thank you very much. Monitor turnouts, take back control. The famous slogan taken from the Brexit campaign should not lead us out of control. It should lead us to a better understanding of what is happening exactly at the rail wheel interface and what we can do to increase the safety against derailments. As mentioned before by Professor Freudenstein, my name is Andreas Oberhauser. I'm the head of track maintenance and permanent way of Wiener Linien, the urban public transport operator operating in the city of Vienna. And it is my real interest as being responsible for metro and tram track safety. It's my interest to present to you the needs which an urban rail operator has in this respect. As already introduced, we shared the presentation. I share it with Mr. Pölinger from voestalpine. In the first part of the presentation, I want to talk about the customer's view. What are the characteristics of urban rail traffic and its needs? What are the typical defects and issues which we experience in metro and tram track and in metro and tram switches especially? I want to talk a little bit about the complexity of switch inspection, and it's our interest to have a better knowledge about time-dependent behavior and about temperature-dependent behavior of wear and further components. The industry's view will later be presented by Mr. Pölinger. On the next slide, I would like to show you a picture about how a metro switch inspection looks like in detail. The picture below shows you the inspection sheet of a, I have to admit, very complicated construction. This is a double diamond crossing with two slips, so the most complicated construction we have in track. The usual switches tend to be a little easier, but these constructions always exist. You can see there are a lot of values to measure, and these values are still, unfortunately, being measured manually. We measure metro switches every 6 months. We measure tram switches every 12 months, still manually. Of course, there can happen some errors when reading from the measurement device or when typing into the database. With the next slide, I want to show you how the metro or the urban rail environment looks like. The both photos on the top line show you typical metro track. As you can see, metro track does not differ that much from a mainline railway track itself. You can see there exists ballast track on the left or slab track like presented on the right. But there are some other characteristics which are really different from mainline railway track. We have curve radii going down to 300 meters or even less. In the Vienna metro network, the smallest curve radius is 100 meters, which is a challenge for maintenance, as you can imagine. In the metro environment, we know axle loads between 10 and 14 tons in general. We have a wide variety of wheel profiles, ranging from the classical Heumann-Lotter profile to the similar to mainline profile Ore S1002. We usually have very steep wheel flanges, and therefore we have undercut switch plates. The tram environment is a little bit different, as you can see. Tram tracks usually share the same road or the same infrastructure with cars or trucks. Therefore, winter service on the tram track is the same as for the road. Therefore, there is a special operation needed, which you find shown on the picture, on the bottom picture to the left. We have to clean the tram switches to get them rid of gravel and dirt in certain intervals in order to keep them safe and operable. The classical tram curve radius is about 25 meters. Again, in reality, it can be a lot lower. The smallest curve radius for tram track at Wiener Linien is 17 meters. As you can imagine, also a challenge for track maintenance or from noise and vibration abatement. You find the same axle load range, ranging from 10 to 14 tons for tram vehicles. And you also find very steep wheel flanges and undercut switch blades, therefore. Now coming back to metro switch inspection itself, I brought you with these slides the typical defects which we find in the metro track. This is first of all cracking or wear at the switch blade as well as at the stock rail, and very important for the risk against derailment is a gap between the switch blade and the stock rail, which has to be monitored carefully in order to guarantee the safety. Another typical defect which is found are RCF defects, which occur at the switch blade and at the closure rails itself. Another defect which we often find is contact between the wheel flange and the check rail itself. This leads to friction, this leads to lateral forces on the check rail itself, and leads to bad ride quality when passing over the metro switch. And the fourth error, or the fourth defect, also very important, is wear or REN fractures of the crossing nose and the wing rail itself. In order to give you some images how this looks like, I brought you some photographies from our track. On the top left, you can find a fracture of the crossing nose on the left. This happened at the double diamond crossing at the depot, not on the passenger track, fortunately, but nevertheless, we had to introduce a speed limit, which is necessary when finding this kind of defect. On the top right, you can find the gap between the stock rail and the switch blade itself. On this photo here, it's not very big, but it is interesting, or it would be interesting to know how this gap varies within time of the year and how it acts due to temperature-induced stress on the switch blade. The photo on the left below shows you the check rail and contact on the check rail. We sprayed color upon the check rail in order to derive the first point of contact. And the closer this first point of contact comes to the very entrance of the check rail, the more dangerous it can get. And if it's too close, you also have to introduce a speed limit on this switch. And the fourth photo on the bottom right shows you RCF defects. I would call them spalling, not head checks, but spalling, which were maybe introduced or caused by the excessive use of lubrication or the lubrication device itself. The next graphic shows you the age distribution of switches in the Wiener Linien metro network. We have a wide variety of ages distributed all over the network. There is a whole lot of rather young switches in the metro network, as you can see, but there is also a considerable amount of old switches, which are of age between 40 and 30 years old. And it would be really interesting for us as an operator to have sensors also applied on these old switches, where you tend to have geometry problems and all that stuff. With the last two slides, I want to give you a short outlook on the tram switches. The typical defects of tram switches are very similar to metro switches. We find wear and cracks. We find a gap at the switch plate, between switch plate and stock rail. We find fracture of the crossing nose or of the filling material at the shallow bed groove. This is a similar defect like on metro switches, but we have also different kinds of defect. As I told you before, tram track is embedded into the road surface. Therefore, there are concrete slabs placed on it, and there is a lot more moisture than in the metro track itself. Therefore, we have the problem of corrosion, which often occurs at the switch plate root itself. And the last two defects, these are not really connected to the switch itself, fracture of the filling wedges or defects of the precast concrete slab. I just added these defects to give you an overall view what can happen on the tram track. And finally, I would like to present you some photos. I talked about corrosion at the switch blade root. On the top left, you can find a fracture which was introduced or which was induced by corrosion of the switch blade root. Of course, we have our methods to repair this damage, but it would be better to not have them in the first place. And the two photos below, they show you also a rail break, which was induced by corrosion of the rail web itself, which in the end led to a rail break, and we had to take out and change the switch quite quickly. So that was a fast overview of the problems which you can find in the environment of the urban rail track operator. And Mr. Pölinger from voestalpine will now show you what you can do against these defects. Thank you very much from my side.
Thank you, Andreas, for providing us those valuable insights into the challenges of a modern urban traffic operator. You did very well in explaining what the challenges are and what the customer's view is, and my task will be now to answer many of your questions, hopefully, and also I count on what we as the industry believe would be interesting for urban traffic operators to have in the network, especially when it comes to monitoring switches and crossings. So the actual goal is to deal with the mega trends that you guys are facing, which is, of course, urbanization. That means many more people will travel in the urban traffic network. There will be shorter times for whatever you have to do in the network. And this is what we, of course, need to understand, that this is now coming to understanding the needs and then coming up with the right solutions in order to ease your pain. So, maybe just recapping what you just said about the environmental challenges that you are facing. We've covered the demographic change, which means many people moving into the cities. Of course, also the windows for doing maintenance and inspection is really much reduced. So the time that you guys will be having in future for doing what you have to do in order to have the equipment in a very good condition will be less and less. And any technology helping you with that, I think, will be of benefit. Of course, the impact on the public also needs to be minimized. So whatever you do is a thing that will be, let's say, recognized by the public, and the effects of that should be minimized, of course. So what are the answers coming from the industry? What are solutions that will be or can be provided to urban traffic operators? Of course, it's to do with the equipment that you put in place. So beginning with rails that you will have in your network with switches and crossings and their signaling equipment, as well as optimizations on geometry and materials. Those are the things that will be of interest to you. And of course, today's topic, which is tailored diagnostic and monitoring concepts in order to help urban traffic operators. So why monitor it all is a question one might ask. The picture I'm now showing is an electrocardiogram of a human heartbeat. And this human heartbeat has, of course, a basic function. Your body is a very delicate machine, and so are critical infrastructures and assets in your network. And what we see here is a typical movement of a hydraulic pump, and this is your heart. And it's got a very special characteristic. What I'm showing now is something that we take from operating equipment, which is similar. As you can see, the characteristics of the green curve is not that much different as compared to a heartbeat. And the red curve that we're seeing is something that indicates that something will happen in future. And this is the critical piece of information we're after. What we're seeing here now is the average lifetime expectancy of human people. When we took a look onto the left side, which is around 1910, so any person being born in 1910 had the average life expectancy of male 62 and women close to 70 years. Over the last 100 years, we've succeeded in bringing this up. So anyone being born around 2010 will have an average life expectancy, male, close to 85, and women even above 90. Which means plus of 25 years, which is not too bad, which is definitely an improvement well above 30%. So why is that possible? Of course, many of those things have to do with hygiene, with times of peace. Of course, if we stop killing ourselves, then our life expectancy would be much longer. But it's also to do with different things like best training. It is to do with innovation in science and medicine. It's also to do with the perfect anamnesis and the diagnostics capabilities. It's also to do with improved care and treatment. So the people that treat ourselves when we do have issues, they are better trained. And this is also an effect on the life expectancy. And of course, it is early recognition of upcoming issues. And again, this is the thing we're after. Anything telling us that something will go wrong in future, that's the piece of information we need to find out. What we're seeing here is when we put some kind of a monitoring system in place, that's the thing we believe will be the outcome. So the monitoring system will be a very good connector between the industry, producing products, as well as the operator working with the products we deliver. And data will be generated, data will be reported back, and this will give us the opportunity to improve the products we produce. And this, again, will have a big impact on what customers can expect from suppliers like ourselves. On the other hand, the right-hand side, we should not neglect, of course. This is the thing that, of course, the operator, which is our client, is after. This is a perfectly happy person that is transported from point A to point B. Yeah, and that gives a very good reputation, and this, of course, is very good for your business, and this is the outcome that you guys will be interested in at the end of the day. So, one of those secrets is creating strong partnerships, and this is something we can definitely say about our relationship that we have established with Wiener Linien. More KPIs on that, on the relationship a bit later on, maybe. Now I'd like to account on the journey that we're on, something that we have started 30 years ago. And I would really like to divide this into 4 steps, and this is perfectly in line with what Professor Veit said early morning when he referred about and talked about the conditions of switches and crossings and how operators need to cope with these. And those 4 steps I'm now showing are totally in line with what he said. So first is data generation. There's no doubt about that data is key to success. And we do that, and if you recall the picture my colleague Andreas showed about the crossing section, we put a sensor literally on top of the crossing. Second step on the journey is we need to transform this kind of data into valuable information. We need to give an indication whether the issue that we are seeing is severe or not. And what are the implications of that? What is the driver? In that case, it could be a worn jack rail, it could be a broken fastening plate, whatever. Third step, this is a difficult one to take. This is forecasting. This is definitely something that we're all after. That will be key to taking the next step to quality, to very good quality information regarding the behavior and the condition of critical assets. And last step to be taken, I think this is one that we will definitely be capable of doing, and that this will be probably easy for ourselves because we do have the domain know-how. This is coming up with a clear action, with a remedy, with a clear message saying what needs to be done in order to prevent what we are seeing. So what are possible measuring points? We heard that metro turnouts are not totally different from mainland turnouts, and this is why I used this particular picture. We would look on to switch machines, for example. So all the behavior that would be implied by operating the machines, moving the switch blades from left to right and the other way around. Those are the things that are critical, and this creates critical data that we are making use of. Second is position of detection rods. So the signaling part of the machine is also being controlled by using monitoring technology. Third will be some kind of vibration, vertical movement measuring. This is always a critical parameter when it comes to, let's say, the quality of the subsoil and the ballast and stuff. Temperature is always a critical issue, as we all know, because high temperatures, low temperatures, having those on the same day, maybe all of that has influence on the performance of our assets. The position of switch blades, my colleague Andreas said, is very close to his heart because that gives indication about the performance of the switch. I will account on that further later on. And the crossing sensor, the tiny little thing that tells you about accelerations, about impacts on the swing-nose crossing, and all of that, of course, creating issues for the railway operator. In terms of tramway turnouts, the situation is not totally different, as everything is, let's say, installed underground. We do see some other issues like the ingress of water into point operating equipment. Those are the things that could be critical as compared to, or more critical as compared to metro line turnouts, but all the other parameters also apply. Noise is something that is very special to tramway turnouts because anyone living close to a tramway line knows about a certain way of creating noise and sometimes disturbances caused by noise. And of course, any loose parts like the covers of the earth boxes, for example, and these things creating noises and issues is definitely something no railway operator wants to have, tramways in this respect. Right. I'd like to show you a short video indicating what switch condition monitoring by looking onto the point machine could be like. So this short animation is again directly linked to the journey that we have all embarked on, which means those 4 steps: data into information, information into prognosis, and then a clear action that will be recommended. I'm pretty sure you remember the slide my colleague presented in all the issues that they would see on a metro turnout, for example. And I would like to account on how we believe this could be solved, or which we are doing already in a way at Wiener Linien. So the gap of the switch blades could be monitored by applying sensors. So these sensors would report exactly about the position of the open as well as the closed switch blade on various positions throughout the turnout. In terms of those rolling contact fatigue issues and spalling stuff, we would definitely recommend to improve rail steel quality or look for the best rail steel quality, taking away a headache from you as an operator. For metro lines, this could also be, for example, the 340 Domain HSH, which is pretty new in our portfolio. When it comes to the entry point on the jack rails, where we would see higher accelerations because the wheel would hit, of course, the jack rail, and when it's worn, it would also hit the swing nose crossings. Those are the things that we're after. And we could solve that by additionally placing vibration sensors and accelerometers, energy harvesting based. So in terms of open space, those things would not need any powering, for example. And when it comes to the issues on the crossing sensor is definitely something that is a good thing to have, because the crossing sensor will let you know about impacts on the crossing itself. This is what the thing looks like in reality. So that's a turnout at Wiener Linien, fully equipped with the sensors I've just shown, and giving a proper picture about the performance of the turnout at Wiener Linien. And now coming back to the KPIs I mentioned at the beginning of my part of this presentation, I'd like to account on 3, 4, 5 KPIs that could be relevant, because that implicates that what we're doing here is real life. This is no school book reading, this is no trials, this is actually live system that we're talking about. So we started already in the 1990s, which is pretty unique. I think at that time we were 3 steps ahead and not only 1. Because applying monitoring in the 1990s was totally unusual. Since then, we have equipped 350 plus switches and crossings in the network of Wiener Linien, which is already a good number, I would say. All of that you will find on 5 metro lines and assorted tramway lines, so both areas are covered. In total, we have installed more than 3,700 sensors into switches and crossings of Wiener Linien. And the good news is, and this is what Wiener Linien is interested in, of course, a very, very high availability, usually ranking well above 99%. We also do have reference not only with Wiener Linien, of course. This is just to give you an idea what voestalpine does in an overall approach, where we have equipped more than 10,000 switch machines already with monitoring technology. We know about improvements of switch condition, switch failures of ranking between 40 and 50%. We do that in 25 plus countries. So on a daily basis, we get into more and more markets because the topic is interesting. And we have equipped more than 40,000 assets worldwide with monitoring technology. So this clearly indicates the trend and where also we as an industry are happy to accompany our customers. Right, and that's the last sentence of my presentation. Of course, we do care about the health of your railway assets as you guys do. Thank you very much.
Yeah, Mr. Pölinger, thank you very much for your kind presentation. Mr. Oberhauser, thanks a lot for your presentation. Quite interesting to see what we can measure in turnouts. Quite interesting to see what are the problems in turnouts really in operation. Now, actually, I saw a lot of sensors what can be positioned in track, and you said, I think, 3,700 sensors are already in track of Wiener Linien. Is this the actual situation that we have not only in Vienna, just all over the world now, a couple of sensors in track? So what will happen in 10 years or in 20 or in 50 years? We are on the step ahead for the future. What do you think about the next steps?
Very good question. Thanks for that, Professor Freudenstein. The thing is, one of the strategies of voestalpine Railway Systems is to equip most of the turnouts we deliver with monitoring. So we would put brain on board initially. So that's the clear way forward. We truly believe that this is beneficial for our customers, for our clients, and that's definitely a way forward, and there's no doubt about that. I hope it's the same view that Wiener Linien has got, but as we learned that there is a big need for monitoring technologies and also a big let's say, idea at Wiener Linien that this thing should be moved forward. We truly believe that we're on the right track.
Yes, of course we share this point of view. And with increasing demand for, let's say, 24/7 availability, at least for metros, I think that monitoring is absolutely necessary. You won't be able to do maintenance if you do not do monitoring when you have 24/7 track.
And do you have now the experience after a couple of years or after this years with the sensors that you have more availability 24/7 with the sensor? Can you measure it that you have the benefits?
We are not yet on 24/7 in our metro network. This is only valid for Friday night and Saturday night for 24 hours operation. But we see that it's important to look back at a time series of measurement values. And that would also be the upgrade which we would like to see in the future. You have to bring it to the end user, all these questions. And the end user for me, as head of track maintenance, is the staff working out in track. And for the staff working in track, it's important to be able to use these tools. So they require an easy to access user interface, which can help them on track to look at a time series, for example, and look how the wear or the deterioration developed. That would be, I think, from my point of view, that is what we need in the future. And voestalpine is already on the way, as we saw in the movie with the new user interface they are trying to create.
The good news is also that the industry, let's say, has, of course, realized that the needs and demands of our customers. And the software is not only a software anymore that will be used in control centers, for example. So it is available on mobile devices, so on smartphones, on tablet PCs, on-site stuff, hands-on people are able to use the information that is provided. So it doesn't really make sense to provide data only into one centralized control room and someone takes decisions there, which is of course the first step. But in reality, the much better thing to have is to, let's say, encourage the people on-site, enable them to make use of the data themselves by providing tools like we have it on mobile devices. And what they should do, of course, is before they go and do something, check the performance. Based on the data they get and the information that is provided, take the right decisions, do the work, and before they leave, they should also check whether everything is okay again. And this is now making use of the latest software.
Good. I see no question from the audience. I hope if there are questions, please give us your thoughts. Maybe one question from my side, additional. Regarding the measurements, you can measure in a turnout many things now. Is it always clear what is the reason for this not normal measurement, what you find? Because there are many defects as we have seen, and you are measuring now an acceleration, and this acceleration is a little bit too high. How do you know that this is a broken rail and not a worn check rail or whatever? How do you know this?
It's a very valid question. As we heard all throughout the morning, that just generating data is not good enough. We need to transform the data into precise information. And this is, I think, where we as the industry can really make the difference, because who else than the producer knows about the behavior of his or her products? And that's the thing. So the example I gave with the electrocardiogram graph, when I compared it to the actual movement of a hydraulic switch machine, just indicates that something will go wrong in future. What we take is the hydraulic pressure, and the characteristics we saw was actually the hydraulic pressure. The thing is that the actual cause, and this is now going back to diagnostics capabilities, is a totally different thing, because this could be to do with not well-maintained sliding chairs, roller systems not being adjusted, for example. That would result in a characteristics on the machine. So you need to understand the asset, and I think this is also something where customers are moving more towards to, and this is considering a switch or a crossing not only as different bits and pieces and parts and separate between signaling and track, but as an asset that needs to function, that needs to work well, and also needs to maintain as an asset. And the information that we will be able to provide will be for the asset, not only one phenomenon, but the total asset.
Good. Thanks a lot.
Thank you.
I see no further questions. Mr. Oberhauser, Mr. Pölinger, thank you very much for your kind presentation.
Thank you.
Thank you.
Thank you.
Thank you.
Sorry.
Excuse me. So we are coming to our fourth presentation now in this block before we get a bigger break afterwards. And the fourth presentation will be given now by Manfred Arndt. Manfred Arndt is from voestalpine Railway Systems. Very long experienced, a very long time.
I hope so.
I see here numbers 24 years. So I can't imagine that you have worked 24 years ago. I think you have been in school at this time.
Work was fun all the time.
Work was fun?
Yeah, work was fun. So we founded the company in 1997 and then 24 years as a CEO. And now I'm switching to a more comfortable job, coaching and advising the new management.
Okay, do you need help there? Because I'm also looking for a comfortable job. Maybe I can guide you in this, in this job.
Let's talk about it after.
Okay.
I'm sure there will be a solution.
Your presentation will be about digital pacemakers in the European railway industry, insights from a rolling stock monitoring perspective. Please, the floor is yours.
Thank you. So, ladies and gentlemen, everybody out there listening, welcome. Thank you for the opportunity to talk about how we can accelerate, how we can make the pace for digitalization in rolling stock monitoring. And in this context, many thanks to ÖBB for supporting us in that aspect. So, I've seen yesterday, I know tomorrow. That's the inscription in the Golden Shrine of Tutankhamun. So indeed, people in ancient times, they had a deep belief in history. They believed that things which happened in the past will determine the future. And of course, you can observe this especially in railways. They carry a lot of history. For example, sometimes they had to do huge investments in the past for infrastructure, which makes it very difficult to change or almost impossible. But if we get stuck in these historical structures, we might end up with decreasing returns. We might end up even in a holding track in our business. But we should not be prisoners of our history. We always have the chance for intervention. And that's why in the following presentation, I would like to talk about what are the mechanisms, what are the obstacles in our way to become more efficient and in the end to move towards increasing returns. Since the essential target, of course, of railways is to stay competitive as a means of transport. What does this mean? One good option is, of course, to improve their processes. And in terms of rolling stock means especially the maintenance processes, but as we have heard before, also valid for infrastructure as well. So how did we start monitoring in the past? People in the field, they gave us some idea about the condition of a track or a specific component, but it was not possible to trace these components, even to make predictions. So we stepped into automation. First steps of automation you can see on these pictures. We try to automate human senses, what people saw, what they see, what they feel, and what they can hear. You see, for example, the TK99 system from ÖBB. The name says it, from the 90s. There's a flat wheel detection, or so-called wild. We manufactured in the 2000s based on strain gauges. And on the right side, you see an acoustic monitoring system from TTCI, where the roots even reach to the late 80s. So the motivation was great, but it also led us to a stage which I would call resistance to change level 1. Because what we created is a very heterogeneous landscape. Different routes, different motivations from different departments led to a system design which was very isolated, very monolithic, with individual electronics, individual software, and as you might know from the field, proprietary interfaces and communication protocols. So if you want to bring together data, they're usually stored in independent and incompatible databases. And especially in Europe, we have a lack of vehicle identification. We do not have really established RFID or even visual identification of vehicles. And last but not least, we have quite complex homologation processes. So this led to, of course, to high costs for operators and suppliers, a low motivation to change, also due to high switching costs. So what was the question for us as a supplier? We had to think of a better solution, how we can make a better and more efficient approach to wayside monitoring. And supported also by the idea of ÖBB, which already came up around 2004 in parallel with Switzerland, to establish checkpoints in the field. And we were thinking of what would be the adequate platform to make that real and to motivate them to switch. So we came to a solution. Some of you might know the modular diagnostic system, Phoenix MDS, which we now already know that is a catalyst for change in the wayside monitoring industry. Every sensor technology which is installed in the checkpoint is based on similar electronics, on similar software, the same operating system. So this makes it much more easy to communicate between these components. It makes us to reduce costs in development, costs in production, costs in service, and this not only on our side, but also on the customer side. You will have less spare parts if you have standard components to service these systems. So what is also a very important characteristic of this platform is that we combine the senses in one brain. This means every information which is taken from the sensor technologies is synchronized with a precise time protocol based on 1 microsecond, and this does almost the same what our brain is doing. When you cross the street, you hear a car, you're 80% sure. If you can see it, you're 99% sure. You don't need to touch it. So this is quite different what was on the market up to now, and we feel that this is already accepted in many countries outside the borders of Austria. What can we measure with this system? Just to give you some examples, some impressions. This is a material fallout of a wheel, a so-called crack wheel. We can detect with our fiber optic sensors. There you have a so-called sliding wheel, which is also causing a lot of damage to infrastructure, and we can get this information out of our infrared detector signal. Next, in the right, you see a defective bearing. Very good also to detect with acoustic monitoring. You see a defect cone, but also defective rollers, and the technology is able to extract from the signal exactly what type of defect it is, if it's the roller, the cone, or something else. More and more important now, visual analysis. In this picture, you see a hanging chain from a train. And this picture now is quite popular, especially in Austria, since people know now how our profile validation works, and people like to stretch out their arm of the window just to trigger an alarm. Last but not least, we can go into more detail. Here you see a safety hook from a cargo door, but you can also imagine you can look at brake blocks, at springs, or any defective component at the wagon or the rail car. So this has become already a classic picture. It's the first checkpoint we installed in Obereisch for ÖBB. And I have learned on Thursday it's not only 40, it will be 47 checkpoints installed until 23. And the next innovation we will add on to this technology is the acoustic monitoring, which will be installed in Lettingsdorf. So what happened? This concept has been visited already by many railway companies. We have now in Bulgaria, in Slovenia, in Lithuania, but even Chinese visitors we had there. And in the best case, they would like to ask for the technical specification to have an easy tender process. So of course this is complemented by a software package, not only one checkpoint, but of course all the checkpoints are in the country, and on top of that, the central management software provides several applications, not only integrating the checkpoints, but the classic one is alarming and intervention for the train operators, and I will come to that now, what we called fleet condition monitoring, which will become very, very important, as I mentioned in the beginning, to improve the maintenance processes. So what does fleet condition monitoring do? We can track individual components of the train. If it's a wheel, if it's a bearing, or whatever we can detect. And we have installed already many dedicated systems up to now. I will give you one example. For example, ProRail in the Netherlands is using it. They have tagged their wagons. And DSB in Denmark, just to give you a number of cost reduction, in the last year, DSB was able to reduce their maintenance interval from 65,000 kilometers for a wheel to 50,000 kilometers. And as you know, this can be a lot of money. So what do we have with these applications? We generate a lot of data everywhere. We have a lot of stakeholders interested in this data. But unfortunately, especially in Europe, all these stakeholders do more than 90% not receive this information. So this is something we would like to change, especially in Europe. And I will explain the next level of resistance, level 2. Why can't we do that? We have, of course, resistance in our organizations. We have traditional structures, I mentioned already. We have individual reasons, fear of losing power, position, or even a department. And I experienced myself in Spain with ADIF when we installed the first combined hotbox detection with a wild system. They asked us to change the software with 2 different logins because the responsibility was in 2 different departments. But after a while testing it now, they might move to bring it like in ÖBB in one responsible department. We have external influence, we have unions, official bodies, but there's one big external impact I want to mention. It is the railway package number 124 coming into action as a European directive, which implies the separation of transport and infrastructure. It was a positive motivation, of course, to increase competition, but for the monitoring side, it brought really some significant disadvantages. It split the interest of shareholders. And I would like to make this clear with a comparison. For example, in North America, here I've mentioned the United States, the ownership of train operation and infrastructure is in one hand. This is quite different in Europe, and the European directive has been nationally done in different ways. I don't want to mention the UK, where infrastructure was privatized and reprivatized, and this split a lot of stakeholder interests. And just as a comparison, if you start a wagon in North America, for example, in Canada, in Vancouver, British Columbia, it can go down to Florida, and all the movements of this wagon will be documented in a database called RailLink, and all the monitoring data in a database called Interis, which is hosted by TTCI, 100% subsidiary of the American Association of Railroads. So this means the motivation among these players is more in harmony and synchronized, and stakeholders can access this information. What is the situation in Europe? Of course, we are divided by nations. I have made a list. In all these countries, only our company has installed thousands of monitoring systems, generating a lot of data, mostly for the trash bin. And why? Because there is no tracking of rolling stock data in Europe. We don't have what we call data roaming and mobile communication. Since decades we are used, and we cross the countryside, that we can continue to use our telephone. It's not possible with rolling stock data. And last but not least, the data is not exploited to the full extent, and all the people who invest in these systems, they are not really able to share the investments. So this also limiting motivation. So how can we establish a digital maintenance service in Europe? We have identified 3 critical success factors to make that true. It's data allocation, because we need identification of vehicles, whether it's RFID or a visual system. It's to clarify about data ownership, who's the owner of the data and who wants to give it, and data security. So these are the key success factors for a pilot. We have started now with ÖBB as the infrastructure side, and with Cargoserve, which is also a company of voestalpine, a small train operator, but also with a lot of experience in maintenance. And we are looking at these 3 key factors. Of course, the needs of the infrastructure and the maintainer, but also we can secure data transfer, how we can integrate automatic billing of this data. And with this pilot, hopefully, we come to a business model which can be spread over Europe. And for that reason, we are also working since years on innovative technologies like blockchain technologies to establish smart contracts so that billing, security, and a decentralized bookkeeping would be possible for such a data transfer. So that's our future vision. And everybody with a good idea, please join us in creating tomorrow, design our destiny, not passively observe it. And many thanks to ÖBB supporting us in that pilot, and hopefully we come to a good solution. Thank you for listening. Open for questions, of course.
Open for questions, for sure. Manfred, thanks a lot for your presentation. Quite interesting what you showed us about the possibilities to measure, and I also think it was quite interesting to see the possibilities in the United States, for example, if they can measure through the whole country. So my first thoughts in this situation was we can gain a lot of information, but then we also have to work with this information, with this data, what we are harvesting at this moment. And I think
you need a domain know-how. You need the capability to interpret this data. Also, we apply machine learning, but even if you apply all these algorithms, you need to know what you're looking for. So this means you need a deep knowledge in what you're looking for. So that's number one. And then you need an application who does not just transmit the data, and this is why I mentioned, I know it was very fast, the fleet condition monitoring application. In this application, all this data is transformed into helpful information for the maintainer, for the infrastructure company as well. So this transfer process is very important, and of course this needs a lot of know-how.
Yeah. But especially United States, if you then have to spread it to different Class 1 railroad companies, for example, everybody is handling the results, the answers in a different way, in a different position, because they have to work then with the data and the
yeah, it's but first of all, they're more used to it. Yeah. As I mentioned, all the motivation, because there is more harmony in the railway organizations. And we can observe this also in other companies with one ownership, for example, mining. Rio Tinto, for example, is a customer. There is no discussion, can we have this information, can we use this? There is more exchange, we feel, of know-how between these individual stakeholders. And maybe I can add something for Europe when I showed this concept that, of course, the distribution of this data is also a challenge. This is why we are looking for a blockchain technology solution that really only each stakeholder gets his data and cannot look into the others. Like when with your mobile phone, you don't want to listen to other people's conversation.
That's it. I'm searching for further questions. I think there are no further questions from the audience, as that what I can see. Maybe one additional question from my side. What do you think are the next essential steps to establish digital maintenance services for rolling stock?
Yeah, not easy to answer, but our experience is, of course, everybody likes to think big. We have several organizations, they have, of course, quite similar ideas, but our experience is that we need to establish working pilots, small steps. We need to get forerunners, protagonists, to drive these smaller projects and get people on board. Better to have early success with a small project than to think 5 years of a big concept.
Good.
Yeah.
Good to know. So I think we are at the end of the presentations, and we will now sum up all the presentations. So please stay here. There are some presenters also here. Maybe Florian and Ferdinand come up to the floor. Now at the end of this session before noon, we should sum up a little bit what we have learned now. Performance based on measurement. This was the topic of the presentations today. And Mr. Neuber already told us today in the morning, performance on track, it is very important. We are now on a new step. We have heard that the railway system itself will get a great future. We all know the topics actually with the future regarding our environment, and going green is something what is quite important for everybody all over the world, and therefore we need the research and we need the new developments. Mr. Pospischil showed us a lot of tremendous, interesting types of technologies, how to measure, and possibilities how to measure. I have the feeling you are preferring the measurement in track. And is this right? And if you are preferring the measurements in track, what is the reason therefore? So please take this micro.
Yes, of course, I'm preferring the measurement in track, since this is my history. I came from the track measurement area, and so yeah, I really appreciate being out there and doing something on the spot. And the technical reason why I think track measurements are very important to be out there and do that on the spot is that you have a different train set coming through. It's the only way how we can measure a track and the behavior of the interaction between train and track is if you are on the track and if you have different trains passing by. If you are on the measurement car, for example, you always have the measurement car and only the measurement car, and it's always the same load. So I think this is one point why we should not, try to talk the track measurements down.
But on the other side, you are always fixed on some certain area, on a position.
Yes, of course.
And it is quite important
you have one setup.
To know this right setup, not to measure on the wrong side. You showed us wintertime, summertime, or maybe if we do the measurement in the tunnel, for sure there's a difference between the tunnel and on the dam.
Yes, of course. Like there are a lot of influence you have to be taken account with, but I think it's the same with a simulation. If you want to have a simulation, you also need all the information from the subgrade up to the weather as an input parameter. Yes, this is what it is, but I think this is a great possibility to do it on the track and get information on the spot. And since our network is quite wide, there are quite a few spots where we can do measurements, so we can choose where to do a measurement.
So just to have to find a
Yes.
position. But this is the reason why we also have Florian here, and Florian can measure not only on one spot, on a couple of spots. Florian, you told us about the yellow machines. Everybody is liking the yellow machines, as you know, and we are quite happy to have the yellow machine. These are your words, what I'm repeating now. Previously, you sold the technology to temp the track. I would say 30 years ago, Plasser and Theurer was a seller for tamping machineries. And now you're inserting new technologies in your tamping devices with the aim that you have more information about the track and maybe to upgrade the time when you have to repair or to maintain the track again. The question is, are you now on the right way? Because previously you could temp every year, and now maybe if you sell a new technology, is this the right way? What is Plasser and Theurer going?
There's a sentence deep in our NDA of Plasser, and it's the sentence of everything that supports the track helps the infrastructure managers and helps also us as a company. And therefore, we proceed in using the latest technologies. And in the future, if the customers demand us for doing inspection via drones instead of inspection vehicles, maybe we also have to think about this situation. But nevertheless, there is, I think, the mixture of the different kind of information, the really physics, indications from inside the track, but also information from outside the track, coming as well as from the wayside monitoring. That the smart task for all of us for the future is to merge the information in the correct way and to use it in the best way. There's a big need for the real physics. There's a need for having analysis on the turnouts, and of course there's a big need for us as the machine supplier to detect the ballast condition. At the end of the day, to present it to the infrastructure manager, and that's what I said with everything that supports track and the infrastructure manager that helps us at the end of the day. So we are fully in line. We do not have any fear if the new tamping machines can extend the intervention cycles from 2 years to 4. It's no problem at the end of the day. We have to do it technology-driven, and there is only one goal in our brain, is that all our solutions have to support the track and the track life. That's it.
I totally agree. If we see the chance what we have at the moment, for example, in Germany, we want to double within the next 10 years the passenger traffic. We want nearly double the freight traffic on our lines in Germany, and we cannot double it with the infrastructure what we have actually, and especially with the maintenance activities what we have actually. But quite clear, we will not get a double amount of infrastructure within 10 years, because in this actual situation, there is no chance. So the only thing is what we can do. We must have a better performance of our track, and we must have a better availability of our track, and we need the access 24 hours a day and not the activities all the day in our tracks. So therefore, everything what you are developing helps really to get more access and at least to get more traffic on track. That's
the goal of all of us.
Yeah. So, Mr. Arndt, I think it was quite clear that you can help us also to understand the track a little bit more in detail and to learn about all these measurements, what can be done now. The question is for me, are we able to understand what you are measuring, and do we make the right answers for the track itself. After that, we have done the measurement and we collected your data. So the next step is to maintain whatever we have to do. And are we able to do this, or do you think we need a couple of years, maybe in 5, 10, or in 50 years?
Just at first, I can tell you we will need a couple of years for sure. But as my colleagues mentioned, there is not one truth in measurement. Railway is a system which is interacting between rolling stock and track. And we have 4 dimensions of measurement. We have onboard monitoring, trackside monitoring onboard, and onboard your yellow cars measuring the trackside. So we have to bring everything together. But your question regarding can we give the right information? Of course, as I mentioned before, we will need expert know-how. You cannot just do this with data analysts which have no connection really to railways. You have to do it together. I'm quite sure, and we have already good results in interpreting all this information. We can detect a lot of defects in detail, but one real big obstacle at the moment I mentioned is that we are not properly exchanging this information between each other. And when we have reached this level, and we can bring, as you said, Florian, to bring all this together, then we have achieved a level for a really good interpretation, also for more efficient maintenance processes, both on the track side, on the rolling stock side, and in the end for more efficiency and for more competitiveness for railways. So that's what we have to do. And just as a side comment, when politicians divided railways in the way they did it in Europe, maybe they did not always look at railways as a system of interaction between rail and wheel. So I think this was a bit overlooked, but hopefully we can take initiatives to correct this.
We have one question from the audience, maybe a quite narrow question from Nishat Kumar, Virtual Vehicle. Thank you all for your nice presentations. We learned that we are generating a lot of data through a lot of measurement techniques. Are we using the data in the best possible way? If not, what is your together opinion on how can we better use this data for increasing the track performance? Maybe Mr. Arndt, you have a question, an answer for this question.
As I mentioned, especially in Europe, I can perceive this splitting stakeholder interests. And what we have to find is a business model which motivates them. Because to answer this question, we are not using this data properly. Most of them are for the trash bin, and we need to find a business model. For example, to give one example, an infrastructure company buys a monitoring system. Uses the data only for itself. They have to do huge investments. They do not share the cost. And in most of the times, we have started several located initiatives, but not a general initiative in Europe. So they are not able to share the cost, and also the data value is not shared, as this gentleman says. So what we need to find is a business model with a benefit for every participant, for every stakeholder, that he is motivated to give his input to a common data exchange, and then we can exploit this data properly. So that's the challenge.
Good. Anybody wants to add something?
It's just one sentence. And we shall be allowed to do it.
And I think next to all of this, because as you said, we want to double traffic on our tracks, so there will be new problems ahead of us, new defects, which we don't know yet. And to detect them, we should never forget that we need people still out there walking the track. Because if we see something in our measurements we don't know, I think it's going to be filtered out. Because it's first off, we don't know what to do with this. So we need people still out there having a look on the track. We should not forget that and try to give them the time to do track walks as well. So just as a comment from my side. Thank you.
Maybe one last, very short comment.
Sure.
Okay, so if you can hear me, I want to quote Lisa Stapler. She has just retired, the former president of TDCI. She gave us the advice, whatever data you have, don't think of to get the best data, just do something with it. Do something with it.
But also for TDCI, they have to do something. They have a lot of data and use this data, and this is the aim what we should have in future. So I would say this is the time to say thank you to everybody, to all of us. Thanks a lot for your kind presentations, to your answers, what you gave us. Now I can close this session, and one very important remark. You are now welcome and invited to join us at our virtual convention, look at railway system solutions and meet with the voestalpine Railway Solutions sales teams. So you just have to change now the area, and then we will see us later on after a break at 1:15. Thanks a lot for visiting this session, and see you later. Thanks. So welcome everybody to this afternoon session, the session after lunch. Maybe it is a hard session, but we have very interesting topics. The session is called Performance on System Solutions. What means we have now seen how to do the measurement in tracks, how to work with our track, and how to take the data from the track, but this is one step, and the next step is now to find the solutions, how we can handle the problems if we have any deterioration in track. And this has to be done in cooperation between the railways and the industry. And therefore, we will have some different presentations, quite interesting presentations. We will start with Mr. Nagl from ÖBB and Nikolaus Neuber from Turnout Service here, voestalpine. The second one is ÖBB Bernhard Knoll and Uwe Ossberger, also from voestalpine. And the third session will be Mark de Vries and Johannes Wundersamer from voestalpine. So now we will start with our first presentation. It will be given by Christian Nagl. Christian Nagl is head of track management and asset development at ÖBB Infrastructure. He is now since a couple of months or 1.5 years at ÖBB, previously in different other companies, and guided by Nikolaus Neuber since 8 years in the company. And I hope you are now satisfied after this lunch, and you can start with your presentation. Do you feel quite comfortable now?
I feel very much comfortable. Thank you very much.
So everything is fine, and now the floor is yours. And
thank you very much, Stefan. Very kind for the introduction. Good afternoon, everybody. Good morning to the American continent. Good evening to Asia. It's a pleasure for us to have this presentation today. And it's a special welcome also from our side today, because we are broadcasting this from home. We are broadcasting, you have seen this in the introduction video, we are broadcasting this session today from WS Service, from WS Academy. And this makes us too very proud, because this is part of the success story of WS Services, which we will explain to you within the next couple of minutes. What WS Service is, who the parties of this cooperation are, and what we do. And in the end, as the title of our presentation, the increase of the turnout availability says, what is the result of this cooperation? Christian, please.
Thanks a lot. Good afternoon also from my side. I will start with a small introduction of ÖBB and what is our topics. As maybe you know, ÖBB runs about 4,900 kilometers of rail tracks in Austria, and our network will currently operated with around 154 million train kilometers. We are working on innovation solutions so that we can look after this network in a timely manner and keep our inspections, maintenance and repair costs low. One of the ways we achieve this through predictive maintenance and servicing based on measurement data. We aim to make a major contribution to the mobility revolution through our infrastructure development. We are also proud that we run 100% on renewable energy in tractation, as you know, and maybe you have seen. And we are also focused on optimizing our tracks to be prepared for the challenges of the futures. Keyword, climate change. We also use permanent measurement of the impact on our track network to identify potential damage and pass this data on to the transport companies. These in turn use this data for their maintenance of the wheel sets. We are also working on building a digital twin of our infrastructure at the moment.
So, and the second party in WS Services is voestalpine Railway Systems. Most of you will know us. As a short introduction, voestalpine Railway Systems, a global system provider for railway components, 66 sites around the globe. And we try to be innovative, we try to be close to our customers, and we try to find innovative solutions. And I have put some overview about the areas of innovation in voestalpine Railway Systems, which is, of course, in the core component area of turnout technology, where we work on high performance and robust LCC optimized components. I just want to mention here the self-detecting switch blades, which we have introduced in the market just recently, about ultra high performance crossings and so on and so forth. But we are focusing also very much on services and maintenance solutions. I just want to mention here, because WS Services is one of these, let's say, outcome of these innovations, and this is turnout and track maintenance services. We're focusing a lot on this, and in the next session, my colleague Vries will talk more about this. We have one of our new areas where we put a lot of effort in is the area of fixation systems, and when it comes to signaling solutions, which is also core of our activities in WS Services. This is, we look into monitoring the turnouts in making them smart. And last but not least, we are also further developing our area in the area of rails, where it's coming into, or where the development is going into head check free rails and or squad resistant rail technology.
Okay. The main challenges for the railways, and thus also for ÖBB, are that we have a great pressure on the availability of the facilities because of more traffic and punctuality targets. The technical demands on the track and the turnout are increasing due to higher axle loads coupled with higher speeds. The budgets of maintenance are stagnating, and it is even our task to compensate for the increased expenditure because of assets grow due in Austria to the Koralm Railway and the Semmering Tunnel,
by increasing efficiency on the rest of the network. Digitalization is the key to higher capacity and optimal utilization of our existing rail network. However, data collection and interpretation is therefore of growing importance. The retirement process of the baby boomer generation of the next years will lead to a knowledge outflow. Additional employer branding and attractive workplaces will be more and more required. The general challenge just described naturally also apply to individual asset components. In particular, the turnout, which is certainly the most critical asset in the rail network. Turnout malfunctions are the cause of around 67% of all track malfunctions. We therefore implement the following measures. Commissioning the turnout as well as carrying out regular inspections and planned maintenance is of importance for the service life and availability of the turnout and has a massive impact on costs. A holistic view of the cost of infrastructure and operations, life cycle costs, creates a process-optimized infrastructure with less costs and more capacity.
So, and as a result of these challenges and also of the strengths of both parties, ÖBB, Austrian Railways Infrastructure and voestalpine Railway Systems have established a joint venture company, which is called WS Services. And this company has two areas of activities. One is called WS Services and is focusing on service and maintenance of turnouts of this highly critical asset class. We are employing in this company approximately 100 turnout experts which are specially educated and trained on the turnout. These experts have comprehensive know-how in the area of track control and safety technology. And we are utilizing in this company predictive maintenance tools to predict turnout failures and to make the turnouts more and more available. As a result, there is the core function of WS Services is the high-performing turnout service and maintenance provider. As a second pillar of activities, we are, as I said in my introduction, we are here in WS Academy. The joint venture partners, our shareholders, have identified, and Christian has just mentioned it, that know-how is a critical topic. And one of our key targets here is to protect the know-how of the railways, and also contribute the know-how of the industry, of the component industry. And we are doing this in WS Services. We are training in this area here around 1,500 people per year in various areas, in the areas of track work, in the area of signaling. And the combination of this extensive know-how between Austrian Railways and voestalpine Railway Systems is, I think, one of the key parameters for the success of these companies, of this company. Apart from our national education attempts, we are also active in international consulting, where we are trying to market, I would say, the WS service approach into other countries. We are active at the moment in China, in Saudi Arabia, Bulgaria, Ireland, but at the moment and recently in Thailand and also in India. So I believe the challenges which Christian has just mentioned in earlier are applicable in many parts of the world and apply to many of our customers. Apart from that, and this is important also for us to, and I will come to that later, is we have also trying to combine in WS Services the two lines of track work and signaling and educate people who are experts in both areas. Why? Because this is an efficient booster also with regard to maintenance and maintenance and inspection. So in total, we can say constant knowledge generation and knowledge transfer takes place in WS Services, WS Academy. Thank you. So From an operational framework, if you ask yourself what is going on in this and how is this working, we have an agreement with Austrian Railways in which we are using dispatched personnel from Austrian Railways, which is dispatched to WS services, and they are employed by us and they are working for WS services, but they even have the right to go back to Austrian Railways, either because they get career chances or, mainly they are leaving WS services because they get career chances in Austrian Railways. The other pillar of success, I would say, is we are focusing very much on individual training of our employees. We know that know-how and knowledge is key, and therefore each employee is going through an individual education path towards what is mentioned as a next, towards the turnout service master. The turnout master is a new job profile which we have just recently implemented also in Austrian Railways, and this person is the mentioned expert, which is combining not only track work capabilities but also signaling capabilities. So we believe that this is the next step of efficiency, and is an important pillar of our activities here. From an operational perspective, we are doing turnout service and maintenance in accordance with a clearly defined catalog of works, which is important for Austrian Railways because it needs to be defined what we are doing and how we are doing it. We are doing it in 100% accordance with the standards and regulations. And in addition, what is also important is that we have agreed at the very beginning on a cost benchmark, because it doesn't make any sense to improve, to change maintenance and inspection activities if you are boosting the costs. No, in our challenge in WS services has been to keep the costs on the same level and by the increase of efficiency to gain profits. And in the end, I can say we are a quite profitable company because of this efficiency gains we have, and this is generating dividend payments to our shareholders, which I believe both shareholders appreciate.
And now looking at the benefits from this consolidation approach from our side, so we can say with this we can reduce the turnout failure and the delay minutes due to the holistic turnout inspection and maintenance approach. Now we have, as you have mentioned, the new profession, the turnout master. This is also for us a contribution to bundle the know-how and is taught in the VS Academy. The foundation of the joint company VS service with a focus on turnout services specifically helps us to focus on efficiency and optimization of the maintenance cost. In addition, it is good for us as a benchmark for ÖBB's own performance. The digital support we are working on for the digital support we are working on the development of the digital turnout file as part of an innovation partnership. This is intended to help us with inspection and maintenance, but also with the right time for reinvestment. The formatation of the joint company by the two industry innovators First and ÖBB also gives us the opportunity for institutionalization, feedback loops to monitor equipment performance and further develop innovative solutions based on that.
And the question now is, this is all theory. Did it work and is it working? And I have brought now, we have prepared two use cases for you to show, to show the benefit of this cooperation. And I have picked one example. We have initiated a pilot project in which started in 2018 and is what we call in Austria the Westbahn project. The Westbahn line in Austria is from Vienna to Salzburg is the high-speed line, highly train frequency, high speed. and we have been awarded. We have been let's say selected as a maintenance party for in this case in 2 steps for approximately 100 turnouts, which are solely maintained and inspected by our company. And after this, meanwhile, 2.5 years, we see a downtime of the turnouts of 29%. So we have been able to increase the availability of the turnouts by nearly 30%. Under, or let's say, with the prerequisites that the maintenance costs have been remained the same and are on budget level. And this is the one benefit, and the other benefit is we are using on these lines constant monitoring of the turnouts. The turnouts are equipped with the voestalpine Roadmaster system, which we use a lot to not to predict failures, but to see anomalies in the turnouts, which enables us to react, let's say, at a very, very early stage. This is part also, and I will come to that later. Also, a benefit of WS services is we have created a kind of feedback loop between all parties, between voestalpine, between Austrian Railways, and between WS services, in which we regularly report on the performance on the turnouts, where we exchange about what is going on in the field, what are challenges, and this, I think, this exchange is very, very fruitful also for the future, and will help a lot, especially the shareholder voestalpine, to improve products, to get more robust and reliable products in the market, and to further develop products in accordance with the needs of the customer. Second project which I have, which we have picked today, is the extended warranty project. It follows the concept basically of a complete support of the turnout over the entire turnout life cycle. So we have the whole life cycle starts with the production of the turnout, just-in-time delivery of the turnouts, installation and transfer of the turnout to the construction site, inspection and maintenance in accordance with the maintenance regulations. And what we have started here is what you have also mentioned earlier. We are not only maintaining the turnouts after installation, but we are also constantly monitoring them. And we collect this information in the so-called Switch Act, the Digital Switch Act, where we are where we are collecting not only all the basic data of the turnouts, we are collecting all the information about which service and maintenance activities have been taking place, which components are changed over the time. So it will be 100% log file in the end for the turnout, and we believe this is a next step in regard of turnout maintenance. It's a pilot project. It has been started. It started 1 year ago. Yeah. So, but we are collecting first data. Data is very promising at the moment, but we believe we need to, of course, continue this project for the next 1 or 2 years to really get evidence and to get, let's say, the cycle moving in a smooth way. But we are very, very positive. And the last thing here in this and in exchange, this is important, in exchange for having the turnouts maintained by WS services and monitored them constantly. The turnout producer, in this case, voestalpine Turnout Technology Zeltweg, has extended the warranty time of the turnouts by additional 2 years. We have increased the years from 4 years to 6 years. And I think this is an additional benefit for the railway operator, because it's about having more reliability, having more predictability, and in the end, having more budget control And I believe in combination, and this is what I mentioned earlier, we have, of course, around this project also institutionalized feedback loops along all stakeholders in the in this project, really to benefit from this additional information we are creating in this loop. And I believe, I hope we have been able to show you a little bit what we do in Austria here, and are happy to receive questions. I think we are at the end of our presentation. Now it's backup about structures, how we work, and so on. But maybe we can, thank you for your attention, and maybe we can, if there are questions, we're happy to answer them.
Thanks a lot from my side.
Mr. Neuber, Mr. Nagl, thanks a lot for your kind presentation. Quite interesting, and especially to see the success of VS Systems technology. It's really impressive what you could show us. So therefore, a short question: why is it such a good performance? What you can show us with WS turnout technologies?
Personally, I believe, and I don't know if Christian, if you would agree, but I think the key parameter of success of our company is, I think we received a very well trained experts from Austrian Railways, but we have been able to focus them on this critical asset. Our experts are focused on turnouts. They don't, as normal maintenance teams around the world, they need to take care of the turnouts, on signals, on whatsoever, drainage systems. In our case, they are only focused on turnouts. So let's say in a grown rail network, you have various turnout geometries, you have various point machines, and even this is already complicated, but our experts are solely trained on turnouts, the respective switch machines, the respective surrounding, and I believe this is key of the success. Yeah.
For us, it's a benefit that we have a benchmark for our workers on the turnouts, because we have a lot of turnouts in our tracks, and only a small part of them will be maintained by VS Service.
And maybe it's another topic too, because we have been able, apart from Austrian Railways, to establish, let's say, a success-based. We have a bonus system implemented in our company. So if the turnout rates are going up, if the maintenance is done properly, people get bonuses. And I believe this is let's say, an atmosphere of willingness to work, to do good work, to do great work, because in the end it pays off for them. There is an individual success behind, and I believe this is maybe a second facet of this success.
Yeah, I completely agree, and especially what you could show us at your practical sample on the Westbahn between Salzburg and Vienna, where you could show tremendously the benefits of such a system. And I can imagine, especially if this topic extended warranty, that all the customers, they have also the benefits, and they see that you take the responsibility for such a new system. This is quite important, I can imagine.
And I believe it's because of trust. This is, I think, is a very important component. It's not only an extension of warranty. It's also because Austrian Railways and voestalpine, they trust in the capabilities of this company, and this is why everybody is willing to support this. Yeah? And I believe this is important. Yeah?
One of the topics of our session. To find solutions, but together, customer and industry are quite important, the railways. There is one question from the audience, Petra Wilfling, voestalpine. It was mentioned that turnout failures are 67% of all track failures. Are you able to split those turnout failures up into, for example, maintenance reasons, product, malfunctions, etc.? Have those figures been improved throughout your cooperation in recent years?
I can only say that not really. And as we are here in voestalpine, I don't say that the components are the main topic. No, I can't really answer that, how the percentage is between maintenance and component failures. But I think it's more component failures.
But I think, and this is the question is, I think is very good, especially in one direction. What Christian has just also said is, I think we are talking a lot about data collection. This is about knowledge. I think we need to admit, in many cases, we simply don't know. And this is why we have the attempt of this turnout file to know in the end, to better understand what is the reason for the failure. How many, it's even the question is that the whole world is digital meanwhile. Yeah? And in railways, I believe we not even know, in some cases we don't know whether we have changed a component of a specific turnout once, twice or three times. So, but with the turnout act, with the turnout file, we know in the end, we know exactly what is going on there. And then it makes things easier, and maybe in a couple of years, when Ms. Wilfling is asking us again, we will have the answer.
One last question from my side, maybe to you, Mr. Nagl. My question always is, we are collecting a lot of data. You are collecting previously this data. Who is the owner of the data? And at least who is responsible to act with this data, what you or what both know? Because sometimes it makes sense to take the responsibility for this knowledge, what you gained now.
Yes, but I would say as an infrastructure company that the owner of the data are with the ÖBB, and we need more digital devices to help our people when they are with the maintenance, or if there's a failure and they have to go on the tracks to use this data when they are on the field. And I think we are operating hard on that we do more with the data that we collect at the moment. At the moment we have the collection of the data, and maybe in 1 year or 2 years we have really the use of the data in the field.
That's also my feeling. There are some railways that they don't like to know about, something about their track, because otherwise maybe we have to take more responsibility than otherwise if we don't know this. But I think the only way is to improve our track and to improve at least the sufficiency for all the customers. We should know how our track is performing, and this is a very good way what you have done. So I take a look if there is no more questions. Thanks a lot for your presentation. Thanks a lot for your kind answers. Take care.
Thank you a lot. Thank you. Bye-bye.
Bye-bye.
So I will switch over to our next presentation. The next presentation with the topic Innovative Turnouts for Mixed Traffic Insights to the European Union project Shift to Rail. This presentation will be given by Bernhard Knoll. Bernhard Knoll is the head of Superstructure Department at ÖBB Infrastructure, and additionally by Uwe Ossberger, Vice President Research and Development Turnout. Bernhard Knoll isn't able to be here today. This is the reason why it was recorded yesterday. So we can now see the video of this presentation, but later on Mr. Ossberger will be here and he will answer all the questions what we have. So take a look at the video.
Thank you very much for the introduction, Professor Freudenstein. Good afternoon, ladies and gentlemen. First of all, I would like to apologize for not being present at today's summit, but the corona crisis has given us new ways of communicating with each other, as well as new digital opportunities for knowledge transfer, which I would like to take advantage of today. Mr. Ossberger, as a representative of voestalpine, and I, as a railway infrastructure manager, on the other side, work very hard every day to further develop the turnout as the most important component in the track. It is the switch that makes the railway traffic as we know it possible today. However, with the increase of the traffic load on the railways and the many train journeys, the availability of these components, in addition to the construction and maintenance costs, has become a much greater focus in recent years. This circumstance leads to a joint research project within the framework of the EU-funded Shift to Rail project about 5 years ago. Today, we would like to present this project and pass on our first findings to you as an interested audience. If you first look at the total costs of a turnout in its life cycle, you soon realize that the production costs are only the tip of the floating iceberg. The greater part of the costs is then the incurred during the approximately 30 years service life in the form of maintenance and fault repair costs, costs for operational hindrances, and the costs for replacing individual parts such as the half set of switch or the frog. If we now take a closer look, we can very often see the following defects in turnouts. Breakouts at the tip of the switch, rolling contact fatigue defects, dipping in the forging area, massive wear and breakouts of materials in the frog and the wing rails, twist and settlement in areas with changes in the track stiffness, ballast destruction, white spots at the common crossing due to the heavy loading, also due to rail surface defects and probably bad drainage. Inhomogeneous load distribution into the ballast bed, and last but not least, the ramping at transition from long to short bearers in the crossing panel, as well as in switch panel in the transition to the open track. Life cycle cost considerations for a turnout with 500-meter radius at high speed and heavy traffic dense show significant costs for ballast cleaning, if recommended, and the replacement of worn crossings and half set of switches. Operational hindrances due to the need of a double track closure in crossovers and tamping in the main and branch line of turnouts increase maintenance costs too. The many changes in the track stiffness in the turnout, combined with an inelastic superstructure without under-sleeper pads mounted on concrete sleepers and rigid frogs, very quickly lead to dramatic ballast destruction once speed exceeds 120 kilometers, 160 kilometers an hour, I would say. In this case, even tamping work cannot bring about the sustainable improvement in the track position, and ballast cleaning or replacement must be considered. ÖBB has already had to rehabilitate several problems along our high-speed line between Vienna and Innsbruck. A more scientific and fact-based analysis of this particular phenomenon, as well as other possibilities to improve the performance of the turnout, which are being tested in several turnouts on the ÖBB network as part of the Shift to Rail project, will now be presented by Mr. Ossberger.
Thank you, Mr. Knoll, for giving these insights from an operator's perspective. I want to go now in details about how we created an improved turnout within the Shift to Rail program. And the first, I want to focus a little bit how to protect the ballast. And this is a little bit theoretical, but I hope it's understandable. First, I want to start with load distribution. So, as many of you know, when a vertical load is applied to a rail, it's not only one sleeper bearing all loads. It's first the rail, which bends under the load, and based on the bending strength of the rail, we have a load distribution and different ballast pressures below, between the ballast, the interface ballast to the sleeper itself. What are the causes then for, or what are the results to the ballast? The first thing, when ballast pressures occur, the particles can rearrange, and this can lead to a settlement. And also edge breakage, particle wear, particle breakage can occur of the ballast, and all those mechanisms lead to ballast settlement and sometimes also to crushed fine grains of ballast, which require ballast cleaning at the end, which is very cost intensive, as Mr. Knoll has shown before. Now I want to go a little bit in details about the structural behavior of a turnout. On this slide, you can see a right-hand turnout. And especially you can see here, there is a black box indicating the crossing bundle of the turnout. And on the diagram below, you can see the stiffness, what the train or the vehicle experiences when it passes through a turnout. And you see first the left wheel or the right and the right wheel. So both lines are indicated in this diagram. And what can you see here? The left wheel experiences far lower track stiffness through the crossing bundle, and the right wheel, it has almost double the size of track stiffness. And especially in the crossing area, where we have this large cast crossing structure, it is even higher. So we have changes in stiffness in the crossing area. And these changes of stiffness, they also lead to ballast settlement and are a root cause for dynamics that occur in the turnout. Now I show a very theoretical diagram. It is based on simulation results from our research partners from Sweden. They have done some very comprehensive simulation of ballast pressures. So this large diagram shows here ballast pressures. Red is high, blue is very low. And if you see here the axis, the two axes of the rails, the outer rail is indicated as the gray box, and then the crossing area is the second gray line or box, which goes through this diagram. You can see that the highest ballast pressures, they occur right at the position of the crossing, but typically on the outside rail. So it's in the crossing area, but it is on the outside rail. And these ballast pressures here, they are far higher than in standard track. So this is a simulation that shows a standard turnout without any countermeasures. So no elastic fastening system, no special sleepers, no special undersleeper pads included. But what can you do about this thing? You can introduce different improvements. The first thing, what ÖBB already uses since 2004, it's undersleeper pads below the sleepers, which have a certain defined elasticity. Second, you can also change the sleeper sizes, because if you have larger sleepers, you can increase the stiffness in some areas, but you can also increase the ballast interface. So if the same force comes down from the vehicles, you have a higher area, which leads to lower ballast pressures. And the third thing is to introduce a resilient rail fastening system with defined vertical stiffness, which has an effect on the load distribution at the end. Now I come back to the diagram what I've shown before. You remember, this is the diagram showing the stiffness of the right wheel. So it was 2 slides before where we had this jump here in the original line. If you try now different countermeasures like wider sleepers, softer rail fastening systems, and so on, you get different distributions then. And with an optimized setup, I have now the same diagram what I had 2 slides before on the ballast pressures. You can have up to 35% lower ballast pressures, which lead to lower ballast settlement, and at the end, longer maintenance cycles for damping and ballast cleaning, which is then very nice on the maintenance costs. let's come to the shift-to-rail demonstrator turnout. With all these theoretical findings I've shown before, we created a project, and this is what is described here in the next slides. I want to introduce very, very quick what is shift-to-rail. Shift-to-rail is a very big joint undertaking. It's funded by the European Union, and it has a total budget of 900 million euros. The funding quote is quite nice. And voestalpine is within Shift2Rail associated partner in the Virtual Vehicle Austria Consortium. And within this project, or within this joint undertaking, we created a project group between voestalpine, with all our subsidiary companies included here, ÖBB as an infrastructure company, Kirchdorfer Concrete Solution as a sleeper production company, Getzner Werkstoffe for resilient materials, and also we were supported by our research partners, Material Center Leoben, Virtual Vehicle Competence Center, and Chalmers University. And our target was, we wanted to optimize the whole system of a turnout, to expand the lifetime of all the components, to stretch the maintenance cycles, or even leave maintenance costs behind. So now I come back to one of the first slides, what Mr. Knoll has shown, with all the maintenance activities that are typically required or damage mechanisms that can occur. What were our ideas and our countermeasures on all those damage functions here? The first thing we introduced 400 grade rails, which have a high wear resistance, which have a high RCF resistance. So all the rails in the shift-to-rail demonstrator turnouts are out of 400 UHC. Then we have the crossing area. The crossing itself is a cast manganese crossing. The crossing is now optimized. It has double strength. It is also manganese steel is wear resistant, RCF resistant. It has a sleeper independency, and so on and so on. And all the other parts here that are focusing on ballast destruction, load distribution, optimization, and so on. We included here elastic fastening system that led to an optimized bedding of the whole turnout to optimize all the transition zones, and also we have introduced in the transition zones some countermeasures that act against stiffness changes. Now I have one slide where we go a little bit in further details about the features we have included in the turnout. The left figure shows the elastic or resilient fastening system, ERL&G, which we have developed within this Shift2Rail project. On the right figures, you see some special sleepers with wide bodies, and also we introduced a sleeper coupling system, which is beneficial in terms of stiffness, optimizing stiffness changes in turnouts. And finally, last September, October, we produced in our turnout facility in Zeltweg 2 demonstrator turnouts for ÖBB. You can see here the figures from our workshop, or the image from our workshop. You see the 400 grade rails with the special machining, dots blues of the switch rail. You can see the sleepers. You can see the polygon setting device, which is included here. The Roadmaster light is included in the point machine, and also the self-detecting switch, which allows to operate this turnout without end position detectors. The focus area, as you've seen on the slides before, was almost in the crossing area. Here we have many new features. We have the ERL&G elastic fastening system. We have the strengthened sleepers. We have new jack rail chairs, which have a higher lateral resistance. Also, the 400 grade rails are included here. Cast manganese crossing, the optimized one, and so on and so on. So, what happened afterwards? So we produced the turnouts. They were installed in track in November. But how to deal with optimization of a turnout? As a producer of turnouts, we don't want to wait 30 years now to show up that our turnout is now beneficial compared to a standard one. That's why we decided to go for a large measurement campaign. We instrumented a standard turnout and also our innovative turnout. And these measurements, they are running right now. We have above 100 channels here included on the two turnouts that show the benefits of this new design at the end. And here is one last picture showing the installation, the test site. It is in the south of Vienna. We have in total 2 turnouts there from the Shift to Rail program and 2 reference turnouts. And the right picture here shows the very proud project group at the end when we produced and installed everything fine. Thank you for your attention. On behalf of Dipl.Ing.Dr.techn.Bernhard Knoll and myself.
Mr. Ossberger, thank you very much for your kind presentation. Quite interesting to see, especially the new innovative turnouts. Now I'm a little bit interested in the validation of this new innovative turnouts. Can you tell us a little bit more details how it can be done?
Yeah, as I said earlier, we set up a large measurement campaign within this project. And yeah, in total it's 2 turnouts, innovative turnouts, and it's 2 reference turnouts. And we applied a lot of sensors to both types of turnouts. And some details here about the sensor concept. We have a large cooperation with Getzner Werkstoffe. They are trying a nice sensor showing the ballast pressures. So they have a sensor, it's a thin foil, and it's pressure resistant, and you can visualize really the ballast pressures below the crossing. And in addition, we have strain gauges, we have displacement sensors, and accelerometers. And yeah, we applied the sensors to both types of turnouts and comparing those signals. That's a quite nice approach. We're running those measurements, or it's planned at least for 2 years, but we had a very extensive start with a lot of additional sensors here. And now we are monitoring all the trends, how it degrades.
Okay, thank you. Actually, there are no additional questions from the audience. So if there are questions, please insert them in the chat. Another question from my side. Quite interesting to see your simulation where we could see, especially in the turnout area, for sure, the frog, it's a very stiff area. So therefore, the ballast pressure must be different to the situation where we are outside of the frog or where it is not as stiff as in this special type of the turnout itself. It can be adjusted with elasticity, and you mentioned different types of elasticity. Can you imagine that in the turnout, each fastening system has another elasticity?
That's basically what we've done in our innovative turnouts. So we have different categories of rail seat stiffness applied. So this is all simulated, basically, to have an optimized transition here from, like I've shown, the static track stiffness. It changes through the turnout, and we try to compensate all those things by individual rail fastenings. And yeah, the problem is that if you have different stiffness, it's always about impact dynamics. So you get impact dynamics from the vehicle if you have stiffness changes in the track. And yeah, that's what we tried here in this innovative turnout, to compensate, to get no impacts from the vehicles to the structure.
And the adjustment is done by the fastening system itself, or do you additionally adjust it with undersleeper pads? Or
undersleeper pads, they are also included here. But in addition to the undersleeper pads, we have this ERL-NG system for, let's say, very resilient fastening or vertical stiffness. But we also have applied rail pads where it is in the range. It's possible to do it with rail pads. So yeah, we have different categories of different systems included with variable stiffness. Yeah.
And just to give me a number, what is roughly the elasticity of a very soft pad, maybe in the frog area, or a stiffer in the rail pad area? What is the elasticity?
Yeah, so the range is, let's say, from stiff, it's around 200 kilonewton per millimeter. And we are going down to 25 kilonewton per millimeter. This is something for the ERL and G system. Yeah, maybe for those people that are also involved in slab track and turnouts in slab track, it's very common, 25 kilonewtons per millimeter, I would say. But for a ballasted turnout, this is a very special thing because you also have the elasticity from the ballast. And now, in addition, you have this resilient fastening of the crossing itself. And this is very nice, yeah, in terms of load distribution.
Do you cover with this elasticity also the requirements of a REMA, for example, heavy haul axle loads?
Yeah, I must say it's also a strength assessment of the whole structure, very important. So we took quite a lot of care about the bending strength also of the whole design, because the crossing itself, that's crucial. We have the impact load still from the wheels changing from the wing rail to the crossing nose. And yeah, with higher deflection, we get also higher bending moments, and higher bending moments cause higher bending stresses. So we optimize the crossing, and of course, this is another limiting factor. Yeah, you cannot make it finite soft. There is a constraint here.
So your solution up to now is more or less for 25-ton axle load. If you have higher axle loads, you would adjust it in the fastening system with higher stiffness.
Exactly, yeah, or even further optimize the crossing maybe towards higher strength. Yeah, that's also possible. Yeah, if you have new challenges, you use new developments.
There is one question from the audience. Ögüz Deniz from Turkey, TCDD. Could you a little more explain about turnout track transition solutions? What kind of optimizations consisted?
It were in the presentation the two transition zones, basically at the beginning of the turnout and at the end of the turnout, or in the region from long sleepers to short sleepers. So you know, in the turnout, in the crossing area with very long sleepers, yeah. And then at a certain point, two track lines, they have now short sleepers, yeah. And this is a very crucial part of the turnout where you have a lot of settlement typically. And we optimized also, or the focus was also on this region, because this is a very nice effect. You get, the settlement is like a twist of the track, yeah. And twist is crucial also for the vehicle track interaction. So there is a certain risk for derailment even if twist is too high. And we optimized this region by different countermeasures. I've shown the wide sleepers. We have the elastic fastening system and also the sleeper coupling, which was shown on one of the slides, which is also very, very nice working, I must say, what the measurements show so far.
Perfect. Quite nice solutions, what I saw. And I just can agree. I think you're in a good way, therefore. Thanks a lot for your answers. There are no further questions up to now. So thank you and have a good time.
Thank you.
So we'll come over to our third presentation of this afternoon. The third presentation with the topic Rail Performance Solutions now for metro systems. Quite interesting, and especially in the metro system, sometimes the area is not enough what we have outside in the main track lines. We will get these presentations from Mark de Vries. Mark de Vries is CEO Region Europe and CEO of voestalpine Track Solutions and Turnout Technology Germany. And additionally, Johannes Wundersamer, Vice President Sales, Mobile Grinding and Milling of voestalpine and Track Solutions. So thanks that you will give us also this presentation, and
Thank you very much for the introduction. Great to be here. Yes, we would like to present to you our solution for metros, rail solution for metros. And to understand the solution at best, we will guide you through this presentation along this agenda. So we will go into the details of the challenges that our customers within metros face, to really understand the problems they are facing and also to see where we need to help them also remediate them. And we will show that you in several key areas the intricate parts of our solution and bring this together on the end. So firstly, the challenges we see in metros, it's very common. I think most of our customers that are operating metros know these problems are, of course, in the rails related due to the fact that actually our customers are facing gradual increases on passenger numbers. So we see they need to increase train frequencies because infrastructure is limited, and therefore they have higher freight loads on their traffic, on the network. Additionally, also the tendency to go to 24/7 operations to make sure that they utilize the time as much as possible is, of course, one of the elements that also brings pressure also on, for example, maintenance slots, to also do maintenance and also preemptive maintenance for the infrastructure. What we also see is all these networks are within the urban situation where you have, of course, a lot of population that you want to also safeguard for a lot of noise and dust emissions, pollutions, and therefore should be minimized. And as last but not least, we're talking about passengers. Every day we're going from work to home and back and forth, and we want to do this as safe and as comfortable as possible. So what we see is actually that the consequences of all these things coming together, that we see an accelerated degradation of the infrastructure components. So you see really big problems in the infrastructure due to the fact we have too little hours to do the maintenance, and therefore we're doing too little and too late to keep the maintenance fit for the job. And on the end, when you need to renew components, it's a very cost-intensive activity because you have very limited space. We're talking about tunnels, we're talking about a very difficult logistical challenge, and therefore it's very expensive to also renew these the infrastructure components. So the typical effects when we go into rail, because we can also tell a lot about turnouts and other components as well, but really to focus on the rail, we see, of course, plastic deformations, big changes on the rail geometry. We see, of course, the corrugation problems in the track that also emit a lot of noise and vibrations. We see also, of course, RCF defects due to the fact that the train loads are increasing, and several others as well, like service cracks and squats. And actually all these things are the main driver for the rail maintenance that needs to be done to make sure that the rails won't break. And if we are not doing that sufficiently, you see the rails will have to be renewed earlier and therefore have a reduced service life, which in turn have higher costs. More disruption can occur due to unpredictable maintenance needs in the infrastructure, and therefore less track availability. And of course, as said before, the higher noise emissions and vibration can be a very big problem in an urban area. And in the end, of course, the worst case scenario could be a safety risk. So to really understand this better, we would like to go into some depth on how we would like to help our customers in solving this problem. And I would like to hand over to Johannes to show us a little bit more about our rail inspection and monitoring technologies we are using.
Thank you very much, Mark, for the introduction about the challenges for metro systems. I have now the pleasure to explain our solution in terms of rail inspection and monitoring. First of all, we have to mention inspection and monitoring is the foundation of every efficient rail maintenance strategy. Together with our cooperation partner, BJM, which is an external partner for us, and an Austrian-based measurement company, we have developed a vehicle-based rail monitoring concept. In our concept, we use industrial sensors, which are temporarily installed either on standard metro cars or on any maintenance vehicle. Generally, we distinguish in this concept between two monitoring missions. The first mission is a complete rail condition monitoring mission prior to any maintenance activity, which is the basis for the maintenance plan. And the second mission is a complete performance, a so-called performance monitoring mission after a maintenance action, which is nothing else than the verification of the general condition improvement and the verification of the defect removal. What do we measure? We measure with our concept the transversal rail profile quality, We measured the longitudinal rail profile quality. The vertical rail wear, of course, is also of big interest. And last but not least, the drag gauge. And it needs to be emphasized with this concept, we don't bring an own vehicle to the client, we just bring the small sensors to the client, which are installed temporarily on their vehicles and which are driven and operated by the operators. In terms of inspection and monitoring, it needs also to be emphasized that the localization of the measurement results is at least as important as the measurement results itself. So how do we localize? Today we have one example with us, which is line 2 of Metro Barcelona in Spain. For the localization of these results, we measure 3 parameters. The first parameter is the mileage. So in this case, we can say this line 2 is consisting of 13 drag kilometers. The second measurement parameter is the curvature, which is represented in this curve by the black line. How can we interpret? So if the black line is going up, it's a left-hand curve. If it's going down, it's a right-hand curve. And the third parameter for localization are the stations. So we inspect or we can detect the stations. And with these 3 parameters together, we can localize the measurement results precisely. Let's come to the results. In terms of the rail longitudinal profile quality, of course, rail corrugation, as shown by Mark before, is one of the main driving parameters for rail maintenance in metro systems. So we have measured the corrugation in this case with accelerometers, so acceleration sensors at the axles. And here at this graph, we can see the results out of these measurements. So it's again this 13 drag kilometers of this metro line. The blue color means everything is okay, and the more the color is going into the green, yellow, or even red direction, this means the heavier the corrugation is. And we can immediately see some hotspots, and these hotspots are corresponding well to the drag curves, where you would expect, of course, corrugation defects at the inner rails. It needs to be mentioned, this is a picture out of this drag curve here in this line 2 at Metro Barcelona, and which is also measured during the measurement mission there. Of course, the rail transversal profile quality is also of big interest, so we can do with our concept a continuous measurement. But of course, we would have thousands of profiles along this line, so you need to find a reasonable number of, for the creation of the report. And here we just show one example. At the left-hand side, we can see the left profile. At the right-hand side, the right profile of this specific position. And the red line is representing the nominal rail profile, and the blue line is representing the measured profile. So we can immediately see the deviation from the measured profile to the nominal profile. And what is also possible is the measurement of the vertical rail wear, which is also of big interest when it comes to the decision either to renew a rail or still to do maintenance. And last but not least, these are the results of the drag gauge measurement. So we can also measure the drag gauge, which allows the operators an information about gauge narrowing or widening for immediate maintenance actions on requirement. Well, now I'll take over again to Mark, who will present you our mobile milling solution.
Thank you, Johannes. So what we just saw is that actually we can measure the problems in the track. So this helps us at least to, let's say, formalize a solution to also remediate the problems. But then, of course, you need the right technology to do so. I would like to show you a little bit more what we have done based on actually our search for the best solution to remediate these rail defects in the track. And therefore, within the metro, we had some requirements we would like to fulfill Like it has to be mobile, deployable between customers. It must fit in the smallest of tunnels and also must fit all the gauges in metros, because a lot of metros have their own network specifications. It has to be self-propelled also to be utilized within the network to go and back and forth from the building site and to also support a very efficient deployment. And of course, we wanted to have the best milling technology to not just do the rail, but also do the turnouts as a total system. And last but not least, of course, with the highest output possible. And so for us, the solution that was found is self-propelled and can go up to 50 kilometers per hour on the self-propelled infrastructure on the logistics side. It is a machine that fits all the smallest of metro tunnels. Even within London Underground, it will fit. It can do both the track and the rail. And importantly to mention as well, it does the milling and polishing in one pass, also to make sure that the noises are immediately taken away after the milling process is done by a grinding stone. It needs to also not leave any rail processing residues. You want to have a clean workspace after you're finished. It should also not have sparks and so on. So there were a lot of things, but most importantly was, of course, we wanted to be able to remediate 1 millimeter of rail defects in one pass. And that was one of the biggest importance for us, with up to 600 meters per hour, to be sure that we can do within a 2-hour window of maintenance at least 1 kilometer of 2 rails, 1 kilometer of track in one go. And of course, last but not least, the adjustment of the track gauge should be 1,000 millimeters, because a lot of customers also have this gauge, up to the wide gauge, the 1686 millimeters, 68 millimeters. What we found was the Linsinger manufacturer was the one with the best technology, with the MG11. So what does this machine do and help us to remediate? And as we've shown you, a lot of rail deflects. You see here a picture of a situation before milling with a strongly deviated rail wheel contact. And after milling, we can really bring that back to the original state of a correct rail and wheel interface. And therefore, the machine is perfectly suited for metro systems, but also other light rail systems, Vignol systems, even also groove rail systems to be supported. And what we can show you here is that we can remediate actually every defect that you can find in the network and bring that back to, let's say, an original rail-wheel interface contact. This is what we call regenerative rail maintenance. It is completely remediating the defects and restore the rails like a new rail. Of course, it also gives us the opportunity to think about other maintenance strategies, and that's what we come on later on within a long-term solution. But short-term, we can at least take away all these problems we've shown you in the previous slides. I would like to show you a video to give you a feeling on what the machine does and how it functions, and also how the technology works. So let's see if the video will work correctly.
Have you ever asked yourself where we are moving to? The more become significant competitive advantages. To keep your plans from collapsing, voestalpine Railway Systems offers an innovative system solution in rail maintenance. The comprehensive product knowledge of our experts helps us to accurately interpret the condition of rails and turnouts. We can then choose the best maintenance strategy together with our customers and extend the rail's life cycle. This saves costs and valuable resources. This knowledge provides the foundation for a mobile high-tech solution with state-of-the-art milling technology, the MG11. It was specifically developed for operation in metros and light rail systems. The small clearance and adjustable track gauge provide maximum flexibility. The integrated milling and grinding technology of the MG11 renders an exact rail profile within a short period of time. The result? Highest surface quality in rails and turnouts. Removed material is collected in the chip container. This minimizes pollution as well as fire hazard. This maintenance strategy renders a silent, smooth rail surface. Product life is enhanced, while life cycle costs are reduced. Because every strategy needs a stable foundation. Voestalpine Railway Systems. Performance on track.
So yeah, that sums it up a little bit on the technology, how it works. But actually, I would like to ask Johannes to show us some examples, because he has been also active with the machine from the first hour and has also guided the machine within our first deployment. So please, Johannes, just show us some examples, if you would please.
Thank you, Mark. So after this very nice video, I have now the pleasure to present you one practical example of mobile milling, which is the best practice example of Metro Barcelona, where we are currently working with our machine. As presented already at the beginning during the topic of rail inspection and monitoring, the main driver for maintenance in this case is reprofiling of rails, first of all, and also removal of rail corrugation in order to increase the travel comfort of the vehicles. In order to show you these two examples, so this is just one practical example of milling of a track curve at Metro Barcelona. Of course, we do measurements immediately before and after milling, and these are represented by these two examples. On the left-hand side, we can see profile measurement before milling of the inner rail, and also after milling, and at the right-hand side it's representing the high rails. The gray line is the measurement before milling, and the green line is showing the profiles after milling. What we can see in terms of reprofiling, in particular at the high rail, is that we can eliminate with this type of technology heavy deformations at the gauge corner and also at the field side with just one or two passes by the milling machine. At the inner rail, of course, it's mostly corrugation which needs to be eliminated, and this brings us to the second example. Of course, we also do rail longitudinal measurements immediately before milling and also after milling. These results at the left-hand side are showing clearly the waves before milling, heavy corrugation, and at the right-hand side we can see the measurements after milling, which are, of course, within the required limits according to the European standard. Well, so rail milling offers us the possibility to restore the rails to an almost new condition. But in this case, we have to mention corrugation and also plastic deformation will show up sooner or later again. And in many, many cases, these types of defects will show up sooner than you would expect. So this brings us to the initial quality. So we have also the topic of optimized rail steels for metro applications with us today. And for these types of applications, in particular in areas of curves, in areas of station where accelerating forces and decelerating forces may occur, our 400 UHC rail steel is represented in this case as the best performing rail steel for metro systems. What is it? It's a 100% Pölinger rail steel with highest material resistance. It's following the special high-strength UHC material concept. And of course, it's also heat-treated by the well-known HSH heat treatment process from voestalpine. The steel material is, of course, also standardized according to the European standard for rail steels. It's weldable with all procedures. And in the meanwhile, there are experiences of more than 20 years existing also in other fields of application. So we can summarize 400 UHC stands for highest availability and longest service life and also reduced maintenance effort. Of course, every new rail steel is compared to standard materials. In this case, we can mention the standard materials R260 and also R350 HT, which is known as the standard heat-treated material. And if we compare the 400 UHC rail steel material with these standard materials, we can mention an improvement, a general improvement factor of 2 in comparison to 350 HT, and even an improvement factor of 6 in comparison to the standard material R260. What does improvement factor mean? Improvement factor means improvement in terms of all common known operational rail deterioration mechanisms like rail wear, corrugation, and head check formation. These improvement factors are also proven in practice. Today we have 2 examples with us. The first example is from Zurich Main Station, where an R400 HD material was laid in after there was an R260. And I think the results which are presented here after the same period in service of 1 year are speaking for itself. I think I don't have to explain in detail. Of course, the material offers a higher wear resistance, but this is not the only benefit in these regards. It's also worth to mention it's also an increased profile stability, which is at least as important as the wear resistance itself. The second example goes into the direction of corrugation. It's an example from Metro Oslo. There also an R260 material was in track, which was measured after a certain period of time with rail longitudinal measurements. And here at the right-hand side, we can see the results out of that. And after that measurements, the client there decided to lay in an R400 UHC material. And after the same time period, a measurement was done again, and the comparison, I think, and the results are also speaking for itself. So this means 400 UHC stands also for slowest development of corrugation. Well, now I would like to hand over again to Mark, who will present you the total life cycle solution from our side.
Thank you, Johannes. So actually, I would like to sum up the things we've just seen, because actually it's not a sales pitch. The idea behind of this we see within proven pilot projects where this rail is really outperforming. And as we said as well, even though milling of rail is absolutely capable to take away all the defects we see in the infrastructure, it's still not a solution. It remediates problems, but the solution is found in both aspects. So actually the solution can be found in the best combination by deciding on the specification on the infrastructure, selecting the best initial premium products to start with, the best quality, and combining that with the best maintenance strategy to also get out of the both two worlds the best life cycle solution. And you see this very clearly stated here. If you just try to make this visually logic, you could say if you start with the initial quality like a 260 rail grade with grinding regimes within a metro, you can reach a certain service life, even though we know it's very difficult to get all these maintenance slots within your maintenance areas. But by selecting a better grade rail that is more resistant against the problems we've just seen, with also a maintenance strategy that can also be, let's say, deployed on a longer time frame. For example, not every year, but every 3 to 4 years. You can immediately change the complete strategy regarding maintenance and also really achieve that expected service life on a very efficient manner. So therefore, we say the best combination lies in combining both worlds with the premium products and the premium services. So to sum it up as key takeaways for us, what does it mean? We would just like to give you 4 things to just keep in mind. Is selecting the premium rails is not just trying to sell you better rails, it's really to try to address the problems at forehand, making sure that the start quality is also the right quality to be able to meet the challenges of the infrastructure. And therefore we have seen within the tests that the 400 UHC rails is the best rail for the metro system. We also have seen that milling is also supporting new maintenance strategies, but importantly to mention as well, also remediate your immediate problems. So if you have corrugation, if you have rail defects or plastic deformations, those things can immediately be remediated. But think about also the possibilities to support new maintenance models like we've shown you on maybe 400 grade with not every year maintenance, but every 4 years, a milling campaign. Additionally, we say the optimal service life can only be achieved when you harmonize the maintenance strategy with the system design. And that has been probably a topic for many of the presenters today, trying to meet both worlds, not just the product side, but also the maintenance side to get the optimal system design in place. So, to wrap it up, the best solution is found in the combination of premium products and services. And that's what we stand for as voestalpine, to really try to get the best result out of your infrastructure. That's what we call performance on track, and to be the innovative system solution provider for your metro network. That's our claim and that's our goal. So thank you very much for us, from our side. It's our pleasure to also have been able to present you this solution and hope to help you in your future challenges.
Mr. De Vries, Mr. Wundersamer, quite impressive presentation what you gave us, especially to see how the milling works, for example, and also the results of the new rail type. Regarding the milling, does the milling work all the time? And what is the border where the milling makes sense? Or, for example, in depth, can I do it all the time? Is there any regulation where we say no, up to this level and we have to replace the rail? Or
technical question, Johannes. Probably that's your area of expertise best.
I will try to answer. First of all, I think it's more a question of philosophy, which also needs to be taken by the client. From a technical point of view, we can mention with milling it's possible to remove, with our technology at least, 1 millimeter of material per pass. If we pass 2 times, it's 2 millimeters, 3 times 3 millimeters, and so on. So technically wise, everything is possible. But of course, this is also an economic question. Finally, our general slogan in terms of material removal is following removal as little as possible and as much as necessary. And everything is also a question about the wear reserves. So if you are already sharp on the edge to your final wear limits, then maybe the rail renewal is the better decision. And if you are still far away from the final wear limits, then a maintenance action like milling will definitely make sense. But finally, I only have to emphasize it's a decision by the operator according to their maintenance plans and strategies.
And especially in the metro lines, after a couple of millings and additionally the wear what we have reasoned by the cars, there is a gap between the old rail and the new rail. What happens if we now have to replace an old rail to a new rail? How can we adjust this step what we have later on?
Well, adjustment is like that. This is always possible for welding. Otherwise, the railway would not work. But of course, it needs to be considered somehow, and this also needs to be considered in this question. Is it the better decision to go for a new rail, or still to do maintenance? Yeah, this is what I can say in this regard.
Maybe I can comment a little bit more also on that respect, on the economical sense. It also is it helps also a migration path from the old school maintenance, maybe not the right wording, but to the new strategy, also to make sure that you remediate the immediate defects, but then also buy some time to also implement another great rail or another maintenance strategy. And that's actually also the transition can also be supported by that.
We check the audience. No, there are no questions actually from the audience. I try to ask an additional question, what I saw. So we have the best products, we have perfect solutions. What gives us the guarantee that it really works?
That's a good question. Of course, it's of course the claim of the best products and the best maintenance strategy, but Important here is, of course, that we are absolutely there also to commit to that claim. That means that if we have to discuss models like performance guarantees or models like a pay-for-performance model, where we both, let's say, generate savings out of the long-term maintenance adaptations within the maintenance strategy, then voestalpine is absolutely also committed to follow that path with our customers. So we'll be there also to discuss these pay-for-performance or also performance-based models, because we understand that it's a great claim, but of course we are also committed really to stick by the customer also during the lifetime of the infrastructure.
Quite good. Thank you. One last question from my side, maybe the new rail 400 HSC. UHC. It seems to me it's a perfect rail for the metro systems. Should every metro use this new rail type? Or is there anything where you would say just for special areas, not for the straight track, whatever?
Of course, you always have to look a little bit more in detail about the local situation. Everything is also depending, as you have mentioned, on the track geometry, of course, in the curves, where most of these defects which has been presented today occur. There it definitely makes sense to use these improved materials. Also in a straight line, maybe in the areas of station, as mentioned before, where you are confronted with increased acceleration and deceleration forces, could make sense. But in a straight line where the load is low, maybe the standard material is enough.
Okay, thanks a lot. Stay here. We still have two other presenters here, Mr. Ossberger, Mr. Neuber. Please come up to the floor. So we'll finalize our session of the afternoon. I think you need a micro. You're the only one who needs a micro now.
Thank you.
So thanks a lot for this very interesting topic, performance on system solutions. That's exactly what we need, the system solutions, especially for our customers. The customers want to have a solution. Not only they should buy anything, they need the result. And I think you showed quite interesting the result. If you think about not only a component, what you want to sell, if you think about solutions, what helps, especially the people from the railways and the people who are responsible for maintaining these tracks. So therefore, I can very good imagine that, especially with your philosophy to investigate the turnouts, to learn from the turnouts, to know how they are working, I can imagine that this will work in the past, actually, and also in the future. So we saw the first steps. What will be the next steps? One step ahead.
I think, as I mentioned in my short presentation, I think the way is towards digitalization in collecting data, but not only collecting, but also interpreting the data and getting into predictive maintenance. I believe the challenges for the railways about a further stressed situation regarding HR will make it impossible in the next years to go to go on track on a regular basis because of some regulations requirement. You will need to go to your components when it's needed. So it's a more focused way of maintenance, a more predictive way of maintenance. So I believe digitalization will help us a lot to tackle this challenge, the challenge of a lack of people on one hand side, but to make it also maintenance more efficient. So this is the next step, I would say. Digitalization and analytics of data. Collecting data, let's say stupid collection of data is not the solution.
Quite good topic. And I have heard in one of the presentations, digitalization is the basis to increase the capacity. I totally agree, it makes sense. But hopefully we don't forget the hardware, because we also have some hardware in our track, and not only the smart rail. we have to take about the turnouts, about the hardware. Mr. Ossberger, I think you have shown us some modifications, how it is working in the hardware situation, and that we also can modify the hardware in a position where not only digitalization is helping us in future, or do you see any other topics what can help with the digitalization in the hardware?
Sure, I fully agree with Mr. Neuber. So there will be major changes in the next years in terms of inspection and maintenance. And this is data-driven for sure. But I also fully agree, we have to work on our products. So basically we sell products to our customers, and the lifetime has to be higher. We have to be better, lower maintenance costs at the end, which are beneficial then to our clients.
Yeah, and especially at the metro lines, we saw that the hardware plays a very big role, and you showed us that it can work, but especially with the narrow curves, with the situations where we have trains every minute or every second minute, it's an increased wear at this situation, and for sure we have to take care about our hardware and the rail, what we have in. One additional question we got now from the audience, Francesco Cortes from TIPSA asks regarding the utilization of higher rail grades. Can this new rail grade 400 be easily welded to a standard rail 260, for example, or will this require special procedures?
Well, as mentioned in the presentation, the 400 UHC rail material is weldable with all available procedures in Europe, and it's also possible to weld them together with the standard materials. Of course, this is a requirement, because if you lay in a new 400 UHC, you have beside, of course, standard materials. So it's a requirement that it's welded also to standard materials, which is, by the way, also the case in these practical examples, as we have shown before.
And maybe coming to the point about the hardware and the software, those two sides have to come together. But importantly is what we, I think, all can agree upon, is to start the dialogue on a more extensive level with our customers to really understand their challenges in the infrastructure. And we are also migrating as voestalpine on more a product-oriented company into really a system-oriented company. And therefore we are also more committed maybe now than in the past to really go deep diving with our customer to find their problems, to find also the right monitoring solutions and measurement solutions, as we've shown as well. The measurement is just a tool to understand what the situation is at the moment and what the right remediation solution should be to come to the right quality again. But in the end, it's a dialogue about how to, let's say, optimize the infrastructure by use of premium products and premium systems in combination of maybe alternative maintenance regimes to make it more robust, to also be able to support our customers also in the long term. And really to stick to the claim to be there also during the life cycle and in the service life of the network. That should be our future goal for the next 5 to 10 years.
A very good close-up of this session. I totally agree. This session where we talked about performance and system solution is only working if we work together between the railways and the infrastructure and the industry. To find the solutions, to agree on both sides that this helps not only one side, also the other side. And I think this afternoon gave us some minds, and I think we will have a big future in these topics. So at the moment, thank you very much to all of you for your presentations. Thank you for your work, what you have done. All the best. I have to say now that we will end with this presentation, with this block at the moment. You're further on welcome and gladly invited to join us at our virtual convention, look at railway system solutions and meet with the voestalpine Railway Solutions sales team. And then the next part, we have a short break now, and the next part will be at 3:15 with the next topic. So thank you very much and see you later. Enjoy the break.